T-shirts are not yet here for logistics reasons. I believe they're supposed to arrive later today, but when T-shirts do get here, we'll coordinate and make sure folks get microphone. Oh, okay, even better. So definitely we should be able to kind of hand out T-shirts by lunchtime or so. All right, is my clicker going to work? So yes, or if not, shortly. But the intention, yes, is to stream the summit. So in particular, the stream is live on the project's YouTube channel. Now my clicker will work. Helps if you have the right window focused. So our gold sponsor this year is the FreeBSD Foundation. And we also are being graciously provided streaming via Scale Engine. So this is our 17th Developer Summit. You can tell that things happened here that we won't talk about. But this is kind of how we're doing. We're about the same as last year this year. Here I have the slide correct. So all the tracks, the talks for this year are going to be in this room, both the working group type talks in the afternoon as well as the kind of main talks in the morning. Lunch is out in the hallway. And then tonight we have a dinner all together in the bottom floor of the Residence Lounge, which is the 90U building. We'll have pizza and drinks. We'll provide sodas, let's put it that way. You can bring other stuff perhaps on your own. So things that are coming up in the future, we have several developer summits later in the year on the calendar. Not all of them have pages yet on the Dev Summit page, but they'll grow them over time. And that's a place you can always check to find what's coming up in the future. So the week after this, if you haven't already booked your travel, it might be a little late. Ed is hosting a hackathon in Kitchener, so June 3rd through 7th. At BSDCan in Ireland in September, there will be a developer summit overlapping with the tutorials, just as we do at BSDCan. Benedict is hosting a hackathon in Graz. I believe you're hosting, right?
Well, organizing.
Organizing, same difference. In October. And we will probably have, well, we will have, but we don't have firm dates yet. We will have a vendor summit somewhere in the US, probably in the Bay Area, but perhaps somewhere else in November of this year. In terms of upcoming conferences for this year, the one that I'm aware of is BSDCan in Ireland in September, as the same place we'll have the Dev Summit co-located with it. For next year's Developer Summit, we will always, as the folks who organize the Dev Summits, we appreciate your feedback. We also appreciate sponsorship to help subsidize the cost of food and AV and rooms and things like that. So if you're interested in sponsoring, please email us at devsummit@freebsd.org. You can also talk to myself or Ed or Deb from the foundation. Also, if there are specific topics that you would find interesting, that you think are something that would be good for us to cover or good for our community, feel free to share that with us as well. And if you have feedback, constructive or otherwise, you can share that. I won't promise that, well, you can share whatever feedback you have, and we may or may not listen. OK, that's for later. All right. OK. You're being funky. So the first talk we have today is actually from the core team, which I also have on my laptop. Oh, and you did this. OK. All right, so with me from the core team today, so I'm on core this time, but not next time. We have several folks who aren't here today, but folks who are here are Benedict Reuschling, Lee Wen, and Ed. as well as myself. And so we'll have a couple of slides we'll go through, and then we'll have some time. I know we're a bit behind schedule today, so we'll try to hurry through our slides and leave some time for y'all to pester us with questions. So I want to talk a little bit about some of the things that we either made partial progress on or things we did during this term, for better or for worse. And then we have a few kind of parting thoughts to the community in general. And then we'll have some time for questions. So what are some things that we kind of worked on this term that we thought were kind of important? Early on in the term, we had an idea, or we had some discussions about trying to reduce some of the barriers, or perceived barriers more than actual barriers, between kind of different types of commit bits. Because we have received, as individuals, we've gotten feedback from other people in the community that sometimes they feel that either there's stigmas attached to certain bits or things like that that we don't think are there. And so we tried to reason about ways to make that smoother and not have impressions that are false. So that's the first thing we'll talk about. I guess, yeah, let me run through them and then we'll dig into them. Last year we talked about introducing kind of trying to have an official project IAM solution matrix. We won't talk about that too much, except that we talked about it last year. Another project that Baptiste started up, we have a kind of a self-hosted video conferencing that's free for people to use in the project. A big one we have been working on in the last part of our term is spinning up a source manager team to manage source. And then I'll talk a little bit about our survey from this year, both kind of the mechanics of kind of how the survey worked this year and going forward, and a few highlights of some results from it. All right, so the first kind of thing that I started talking about was this notion of having a more unified view of commit bits in general, and trying to remove any stigmas that might be attached to them or not to them. So we sent an email back in 2023 where we kind of outlined a plan that we think in particular for one of the aspects is if you are committing to a repository where you don't have a commit bit, but you have a commit bit in another repository, and those have in the past been kind of special. And some of the specialness was just an artifact of the fact that when we originally split our repository into 3 separate CVS repositories, we had to have 3 separate access lists because the access list lives inside the repository, like just because that's the way the Perl scripts worked. And then over time, some social things got attached to that weren't necessarily intended from the start, as much as it was just a mechanical feature of like an artifact of how the ACL checks worked. So we sent an email kind of saying that we wanted to kind of alter some of even the rules that we have in place about how you have to get commits approved when committing across repositories. That in general, we think you should just get review when review is warranted, whether it's within a repository, you have a commit bit where you normally commit, or if it's in another repository. That it should be up to each committer's judgment of what review makes sense and when to get approval, when you're doing something that you feel really comfortable doing, or when it's something that's kind of outside of your area, and kind of use your own best judgment. So we sent an email about that. We got not a lot of feedback. The feedback we did get, those seem to kind of generally agree with the idea from developers. The thing that we kind of failed on doing is that then we needed to turn around and write up deltas to our rules in the committer's guide to actually kind of formalize it. And we didn't do that. And so that is one thing we will probably talk with the next core team as a suggestion of something they might want to pick up, or that we would like to pick up and maybe we'll help them with. One of the changes we did, though, take during this discussion is we used to kind of annotate when a commit was made. If a commit was made by someone who wasn't a committer in that repository, we'd add a little annotation saying that you committed to repository foo, but you have a bar bit, and we've stopped doing that to kind of make all commits just look the same and not calling attention to those commits. So we did make that change. One of the other things we've talked about a bit, as well, kind of that's related to this, is right now each repository has somewhat different rules for how we deal with idle commit bits. And when we retire someone who's been inactive and kind of take their bit in for safekeeping, part of this is that we have different rules. Like I think some repositories have longer timeouts than others. In some cases, it's also some trees we are better about enforcing the rules, and some trees we are lazier about enforcing the rules. In particular, source, we're pretty bad about actually harvesting bits. I didn't put it on the slide, but actually, This core term, we did a better job of paring that down. I think we started with like 20 or 30 people on the list of who are getting reminded all the time by the Grim Reaper, and now we're down to like 4 or 5. So that at least is somewhat better. One thing, though, we did talk about this idea of kind of bringing more unity to commit bits in general. We do think that it still makes sense that there is some kind of meaningful distinction between where the tree you kind of typically work on. So for example, we think that ports manager should still approve ports bits. Like that they're the ones who are the best ones to make decisions and evaluate who's contributing to being active in ports and kind of warrants a ports bit. And the same with doc. And we believe for source that will be true with source manager. Like we don't think, for example, that core should then decide to approve all commit bits and there should be one giant single access list. I don't think that, or really don't think that makes sense.
Alan,
Yeah, Alan, do you have a question?
So when you talk about unifying the expiration policy, does that include something like if you're still active in source, your ports bit doesn't expire even though you use it?
No, I think it's more about having them all be 12 months, for example, and all be consistently kind of enforced. I think we would still see it as you can have multiple bits active, and each of your bits acts as a reference count on your login account, if that makes sense. Like that you must have at least one to kind of keep your login shell working. So last year, we won't talk about it a whole bunch because we did spend quite a bit of slideware on this last year. We did announce a kind of project-sanctioned IAM service using Matrix, matrix.freebsd.org. So that's been up for definitely over a year. It's still kind of the development instance, and we're still kind of standing at the production instance, but I know people are using it. Certainly, Core used that as kind of our main internal communications channel rather than IRC this year, which was helpful because then you don't have to deal with everybody losing ops and then having random people spamming things you don't want to see in IRC from random bots. And certainly some other teams. I'll get to Source Manager in a second, but those of us who've been kind of brainstorming and working on that for quite a while, that's what we kind of used for our channels to talk with. And I know the other teams are using channels on Matrix as well. One that is kind of new that we've been using but haven't talked about before is Baptiste stood up an instance of, and it's French, I know I can't pronounce it right, so I'm going to butcher it as English and say Galeen, but I don't know how it's pronounced. But it is an open source video conference solution that works on FreeBSD, also works on other OSs, but people have been able to use FreeBSD on their laptops with like Firefox to connect and work with it with a webcam. So it's a pretty stable server that runs. It's like runs in a jail on one of the machines in the cluster. And it works decently well. Occasionally, sometimes we'll have glitches with video and audio. I know Warner and we had fun with it 2 weeks ago. But usually it works pretty well. It's kind of, right now we currently have it kind of open so that it doesn't require any authentication to join a conference that you want to host. We'll see how that works, if we can kind of keep it that simple or if we'll have to change that in the future. We believe that our intention is that this is available for if you're doing something that's FreeBSD related, this is a place you can go and have a free conference room without time limits or without other limitations that you can use to host a meeting, if that makes sense. We've been using it as Core.12 for like the last year or so, or at least the last several months for all of our meetings. The folks who have been kind of meeting and that I'll talk about in a second with planning it out and brainstorming for Source Manager, we've been using this for better or for worse. I know also Port Manager and some other teams like the graphics folks are using it for their meetings as well. One caveat with it is that it's designed for use in kind of lecture environments. I think it was developed during the COVID lockdowns. And in particular, one of the things is, while it does have a way to do recordings, the recordings are not quite what you would get from something like Zoom. And that what it decides to record is everybody's individual incoming feed as a separate file, and then muxing those together and mixing the audio and making a nice pretty display that shows all the cameras is left as an exercise to the reader. Which is, if you're used to using a recording like Zoom, that's not what you're expecting. So I don't know that we've actually used the recording feature much in Core. That didn't seem to be very beneficial. If you have questions about this, there will soon be, if not already, a meet-admin alias that you can email that will poke the right people. In particular, if you want to know how you create and host a group, you will need to email to ask that. That's not on the slides. OK, so one of the other things I've mentioned a couple of times that Core has worked on this term has been standing up a source manager team to kind of be the oversight of the source tree and kind of moving that responsibility out of Core and having Core become a body that oversees kind of the various hats instead of having source policy live inside of Core itself. So Ed Mast, myself, Warner, and Mark Johnston have been kind of meeting on and off for, I think at least 9 months. I think Mark and I might have even started longer than that. I think we talked about it last year at BSDCan even. So we've been having lots of discussions and trying to think about what makes sense in the context of a source manager team, what types of responsibilities and roles such a team would or should have, what things it should have oversight for versus not, and trying to understand how it would be comparable to like port manager and dockeng, and what things kind of would still live in Core's side of the fence versus source manager's side of the fence. So we've also spent some time kind of doing things like bug triage or looking at the open GitHub PRs and trying to do some kind of just working through that to try to get a good feel for what we think might be sensible policies to start doing in the future so that we kind of get our hands dirty and are not just making policies out of thin air, but doing things based on experience and what seems to work well. We've gotten to the point that we've written a draft charter that's currently being reviewed by Core. So hopefully that we'll kind of go round and round with Core on that in the next week or so and get that finished up and affirmed before the next Core team is stuck with it, so that we'll have it finished and not on their plate to deal with. That's our firm intention. The kind of high-level description is that similar to port manager and dockeng, that source manager will be a team that oversees things that are source-specific, as opposed to things that cross multiple trees. So specifically, source commit bits will be something that belongs to this body rather than to Core. So they'll be responsible for approving new commit bits, managing the revocation of idle commit bits and things like that. Defining policies, for example, when is it appropriate to commit, what types of things or to commit to source, what types of rules or policies are source committers required to follow that are specific to source as opposed to things that are generic across all the trees, things like that. And then arbitrating disputes that are kind of within source land. For example, I know port manager sometimes kind of deals with disagreements or disputes that arise between ports committers or ports contributors and committers, and source manager will have a similar role when it comes to things that are contained within source. If something is between teams, that's something that still needs to go to Core, and Core will be the ultimate arbitrator and kind of like last court of appeal for anything that happens inside of any of our teams, whether it's source manager or port manager. OK. So how are we doing on time? So I don't have a clock in front of me. Oh, and it's the wrong time zone. I'm completely screwed. I'm still in California for another 3 weeks. So the last topic we want to talk about before we the last topic of things we worked on is our community survey this year. So one of the things when we came into Core this term, this was one of the things we wanted to kind of make more firm or make kind of a firmer basis for. So we've had some previous community surveys, particularly some previous Core terms in 2019 through 2021. And those did happen for those 3 years in a row, but then they kind of fell off when the person doing them either didn't do them or kind of wasn't available or something like that. Also, the way that happened, because of kind of just the way the survey was administered and run, the results of those never got published publicly. We would talk about them perhaps in like a Dev Summit. We might go over some of the results, but we never published kind of the raw results publicly, which was something I personally was not very excited about. So some goals that we had is we wanted to have, we think a survey is useful. We think it gives us useful data that we don't otherwise get. Like at the Dev Summit, we get good feedback often from many of our kind of commercial downstreams and vendors. But there's a lot of users who we don't hear from directly at conferences. And we would like to make sure that we're getting kind of as much input as we can and data from various consumers that we have as our downstreams, because we have all sorts of different users that use FreeBSD. And we think the survey is a useful way for capturing more of that data that we don't currently get. But for that to work well, we need it to be consistent. Some of the data that we care about is things where we want to observe trends over time. And the way we're going to observe trends over time is we're able to ask the same question year over year and see how the data changes. Some of the things we ask are kind of one-off in-the-moment questions, but a lot of things that we want to have data about are what are the trend lines in our community? How are things changing over time? And to do that, we need to be able to have data that's consistent year over year. And so we need a way to make sure that it's happening every year. And also, we definitely want to the extent that we can, publish the results publicly and on a kind of consistent basis every year. Some things we don't feel are appropriate. In particular, anytime that there is a response that's a right-in answer, we don't feel those are appropriate to share publicly, at least without some kind of anonymization. But like for many of the questions, they're like multiple choice or multiple guess, or yes, no, or something like that, and you can get a simple bar chart. Those we definitely feel should be something that should be shared every year with everyone. So thinking about our goals for this and ensuring that, in particular, we have this sustainable process that's going to happen year over year, we reached out to the foundation to ask them if they would help with this, if they would help kind of ensure that it happens on a consistent basis and kind of have oversight. We also, one of the things they asked from us, though, is that we would like input from the project about what questions you want to ask to make sure that we're asking good questions and getting good data for both the foundation and the project. So we partnered with the foundation this year to kind of help provide stability and ensure a consistent process going forward, not just kind of one-offs, but year over year. And we had some members of core work together with folks from the foundation to kind of go over the survey and develop the kind of questions. And I expect that that's going to be something that happens every year where we'll refine our question set collaboratively every time. And one of the things the foundation did is they brought in a survey consultant to kind of help both with working through the questions and tweaking and understanding what we wanted to ask and giving us input on how to frame our questions, but also doing some kind of deeper dive analysis of the results that we got back. So let me go over a couple of results to kind of explain how that looks and why that's different. Yes, Alan?
Have we come up with any ways to make sure more of the community, especially the ones not necessarily on the mailing list, actually know about the survey and participate in it?
So that's a good question. I don't know if we have a good measure of how effective. So I know that the foundation in particular tried to blast it out on all the social media channels that they have access to. And I know some individual FreeBSD developers did that as well and tried to advertise it as widely as we can. I don't think we have a way of measuring where people found out about the survey and where they came from. But that's not one of the things we asked. Maybe that's something we'll ask in the future. But for myself, I don't have better ideas. I know another issue we ran into is we used a specific provider because that provider has features that kind of work, but they also had limitations like they did not allow people from certain parts of the world to participate. And which was a kind of a trade-off. And there are no perfect answers there in terms of like having the functionality you need to do a survey and some of the reporting you want to do versus dealing with that, because they all seem to have the same constraints. But let me go over a couple of the results just to kind of give you a sense. So here's one raw result and the apologies that ScaleNet made it kind of unreadable. So one of the questions we asked, which will be a kind of year-over-year question to spot trends, is which architectures are people using? And I think that there might be some kind of, this might be consistent with kind of the project's recent direction that we're going to be moving to retiring many of our 32-bit platforms in the next couple of years, given the kind of the raw responses. Although an important point to note is that like the survey is one bit of input data, but it's not the sole basis for how we'll make decisions. In particular, RISC-V is kind of a special case because RISC-V is a newer architecture that's still kind of in its growing stage. There's not as much sand with RISC-V. It's harder to get sand. Like I only run it in QEMU myself, but sand is coming. And so like it has stuff that's coming in the future. Meaning there is some sand now, and that's going to get better. But like, that one's still coming, and it's also very actively maintained if you use other metrics, if you look at how many commits it gets in a tree and so forth. So even though it doesn't currently have a lot of expected use in the next 12 months, it has several other metrics that point to kind of a pretty healthy developer ecosystem around it. But this is kind of one data point. But when you look at a raw result like this, all you're getting is the answers to that question. And you don't have more context around it. So one of the things when we worked with a consultant, they were able to kind of cross-reference things across questions and maybe provide kind of different levels of detail about a specific question. So here, for example, in one of the slides from the kind of results that the consultant came up with, you can see that they were able to break down kind of our kind of people who use FreeBSD in a work context, like at their job, versus people who are using it kind of individually, and kind of what maybe different preferences. They're not tremendously different, but there's some differences in terms of which kind of, are they more prevalent in one environment versus the other. But also I really like this little nugget, which was people who said they were going to use ARM in the next 12 months, most of them mentioned that the primary way they were going to use, that the primary workload they use FreeBSD in is in a cloud. And so that's kind of a neat little, and I think many of us believe that's probably true, that we think like Graviton is how people are using ARM64. But instead of it being an anecdote that we kind of have as a gut feeling that we think is true, it's actual data to say that, yeah, your gut feeling kind of is true. Alan?
Do we have numbers on this over time from even just the previous surveys to say, you know, we see RISC-V is growing, whereas ARM is shrinking?
We don't have good numbers over time because of the previous results, no. But our hope is that going forward, we will start having results over time. But unfortunately, we're having to start kind of, this is our baseline this year. And that over time in the future, now we'll actually be able to start seeing trends as opposed to starting off with this is our baseline.
Real quick, it might be helpful just to, I've got it pulled up here. So we had about 1,500 respondents, just shy of 1,500, who heard about the survey through, kind of as you said, John, a variety of means: email, Twitter, FreeBSD News, Reddit, Hacker News, and some other media. And that sample size provided 95% confidence, plus or minus 2.6%.
And one of the things, yeah, I don't have it in front of me. Some of the annotations that are in the report, for example, certain numbers being surrounded by a box, that indicates like a higher confidence for that particular response or that particular thing that was being measured as opposed to others. There's a key at the beginning of the report that talks about it and explains what the annotations mean. So I have two more kind of things from the report I wanted to talk about. One of them was, I know some of us have kind of, one of the things that came up in some of our internal discussions in core this term was we kind of had a perception that things are a little different, to kind of be very direct, in source versus ports. In terms of kind of where the work originates and who is active. We kind of had a sense that a lot of work happens in source is basically paid for by somebody, whether it's an employer paying a developer to work on things in source, or someone being sponsored in some way to work on things in source. Whereas we feel that in ports, the most of the work is actually done on a volunteer basis as opposed to being sponsored work done kind of paid for by an employer of some sort or a company. So one of the questions, one of the things here, there's a couple of things on this slide. We kind of asked people, are you a committer versus someone who's not a committer but is a contributor versus a user? And then we did our consultant kind of did some cross-referencing of that, lined up with, do you identify as a ports person primarily versus a source person primarily versus kind of other roles? And you can see, for example, that we have a higher share of people who consider themselves primarily individual contributors as opposed to corporate users. They outnumber corporate users in ports, and then in source it's reversed. So that kind of matches up what we were thinking internally in core. But again, instead of it being a gut instinct and an anecdote that we think is maybe true, but we don't really have confidence in, we at least have some data that seems to back up the things that we think we've observed. Colin?
On that point of people getting paid to work on FreeBSD, maybe next year's survey we could divide up not just do you use FreeBSD at work, but do you work on FreeBSD at work? Because I know there's a lot of people who are your sysadmins and they administer FreeBSD servers at work, but their contributions to FreeBSD are all volunteer work.
Right. And in particular, there's also one of the things that I think has come up in our discussions post-survey is there's kind of actually two meanings for what makes corporate versus individual. There's kind of the downstreams, people who consume FreeBSD in those environments, and there's kind of the contributors and how are you contributing. So you may be contributing out of a corporate environment, but then also you use it at home on your laptop, which is not a corporate use case. Or like if you're running desktop, you may work on something that's a very server workload and work, but then use KDE at home. And those are not quite a one-to-one matchup, right? Those are different use cases. And then on the reverse, you may be someone who is doing stuff, maintaining ports on a volunteer basis, but actually that turns into somebody else's product that they're using downstream in a different consumer. And then I had one more. And there are several questions that I think are interesting, but we have limited time. And I would encourage y'all to go look at the results. I know the link was sent to developers. You can download both the raw PDF, kind of like the first question, but also this presentation that has these kind of more annotated and refined results. So this was a question that was kind of, the main question is kind of how did you first learn about FreeBSD? And then the thing that's kind of interesting here is we were able to split it up based on how long have you been using FreeBSD and compare how do people who have been using FreeBSD for a long time get introduced to FreeBSD as opposed to people who are newer users to FreeBSD, and to understand how those populations differ a bit. So for example, many of us graybeards, because I'll put I'm definitely in the last column, we mostly found out about FreeBSD through word of mouth. Or some of us discovered randomly on our own, but our primary thing was word of mouth. Also, like myself, I was exposed at school. That's kind of where I first learned about FreeBSD. But those trends don't quite match up the same for more of our younger crowd and our more recent users. We still, for those users, actually many of them are finding it randomly on their own, which is maybe not the best way to find out about us. We would rather have a more deterministic way. But one thing I found really interesting was this one that has grown over time, which is researching alternatives. And in particular, when looking at some of the kind of right-in answers, primarily what people would mention is alternatives to Linux. And so that our younger kind of users that we are attracting now, they're looking for something as an alternative to Linux. So maybe one of the things we need to think about, for example, with our documentation going forward, do we need to have more tailored content that's for those types of users as opposed to just generic how to use FreeBSD? Do we need to be explaining a bit more of how do you kind of map what you have a model in your head of how Linux works, and how does those kind of concepts carry over into FreeBSD to be able to cater to that specific kind of demographic that's now making up our younger users? Or newer users, perhaps. Alan?
Was the podcasts and things like that an option on the survey for how people heard about FreeBSD?
Yes, actually, yeah. We just don't have all the questions up. No, so like one of the questions we had that's kind of interesting is we asked like, how do you stay current with FreeBSD? How do you find out? And there was a lot of diversity on that. It is true that, for example, committers and people who've been around for 15 years love to use the mailing list to decide what's going on. And that's less true if you're either a contributor or you're younger. And definitely things like the podcast, even the journal, kind of rated pretty highly in terms of places people would go to kind of keep up with what's going on. And I don't think that was very surprising. But again, in many cases, there are things that many of us who talk about, we may have a sense of how things are working, but we just have a sense, and we don't have good data. And starting to have actual concrete data, especially if we can establish in the future year-over-year data, will give us much more confidence about making good decisions as opposed to being more cautious because we don't know if it's a good decision or not. Warner?
One question about coming from Linux is, do we have a sense from the survey, or maybe we need to add this next year, of how important certain core Linux APIs that we don't implement are for people that are trying to do an alternative? And API is kind of a big net, everything from system calls to minus mumble on some command line that everybody's used to using, or having improcs in the base system, or stuff like that.
We didn't ask that, so no, we don't have that data. One of the things I think that we've learned this year, and we'll probably learn every year, are what are some things we want to ask going forward? I know personally one surprise I really had was we had a question it said, what server workloads do you use? But it should have been a more accurate question is kind of what use cases do you use FreeBSD for? And half the people that responded to the survey said they use FreeBSD as a development environment, which was higher than I expected. And I think that's a question for next year. We'll want to kind of do a bit more deeper dive on, well, how are you using it to develop FreeBSD, or are you using it to develop other things and using FreeBSD as the place that hosts your IDE and so forth? So that would be very interesting to know kind of which one of those it is, because I actually don't know which one of those that is. Because that wasn't the result that I expected, and I think that's a useful one to find out more information about. And there's other things like that. So when we find things that maybe don't match what we expect, that's a good time to think about, well, what do we want to ask next year to kind of get more refinement and better understand something that we either wasn't something we expected or was kind of what we expected, but we need more data about it. So it's good to think about what we want to ask next year. Okay, so we have one last thing. We had some thoughts as a team of things that we think are helpful, either perhaps to the next core team, but in general, these are more useful to the community at large. I think most people already know this, but it's good to always keep in mind that members of the project, we all have limited time to do things, in particular, limited volunteer time to do things. Many of the times when we do get sponsored to work on something, we're sponsored to write code, more or less, as opposed to do other things. So it's always good to remember that folks have limited time, and we have all sorts of obligations like family and so forth outside of the project. And so sometimes when things don't move as fast as you'd like, or as quickly as you'd like, or smoothly, it's unfortunate, but that's also, we're not happy about it either, but it's just kind of the reality of the constraints that we have. So always keeping that in mind about each other. One thing that's really helpful, especially in the context of a core team, is the more people that are active in doing things, the less amount of work there is per individual. You can spread the load easier if you have multiple active people. Whereas if you have fewer active people, then you have more people trying to carry more weight at a time, and sometimes that just doesn't work out. So anytime you see something that you could be helping with, or see something that just needs to be worked on, go work on it and help, because the more people that are active in doing things, the less work there is that each of us has to do as an individual. Another thing that I think we kind of know in the community, but it's good to know and maybe not always obvious to folks who are newer, is a lot of things that happen in our community, we're not a very top-down community. We are driven a lot by consensus and a lot by things that just happen within people in the project. So a lot of changes that happen inside of our community, whether we adopt, for example, when Fabricator was stood up, that wasn't something that core decided it wanted to do. In fact, someone else did it, and core kind of said, oh, that looks neat. We think that's probably a good idea, like maybe a year later. So a lot of change that happens in our community and things as we evolve over time, it's kind of driven internally by individual developers doing things. So if there's kind of something you think would be useful to change, a lot of times, just starting to do something different and starting to kind of cut a new path through the forest, as it were, is the most effective way for that to happen. One thing that's kind of one of my personal things that I'll get on my soapbox for a second. A lot of things in our community, we try to work by consensus. We try to not have a lot of top-down direction. We try to have things where we kind of have a lot of freedom and autonomy as developers of where we want to push. But one of the things that makes that tricky is you want to actually know when you have consensus on something. One of the properties we have in our community is when someone asks a question or makes a proposal, people who disagree with the proposal will voice their disagreements because you care strongly when you disagree with something. But we don't have a very good culture of saying, yeah, I think that's OK. So a pretty common thing that happens in our community is someone will say something, make a proposal or so forth, and we'll get like a handful of replies saying, yeah, that's kind of, but I don't like this part or this part, and then no one else responds. And so do the people who don't respond, is it because they agree with the thing and they are, many of us older people grew up with downloaded email over modems, and so we were all trained to not respond to emails unless we actually had something meaningful to say as a lot of content, and to trim or quote, trim your replies and so forth, because we're all worried about how much we're paying for our dial-up access still. If we're operating under that mental model, then we're hesitant to reply and say +1. But actually, getting the +1s is really useful to understand, is there really consensus or not? And I think in our community, we still are pretty weak on giving the +1s. Like we either feel guilty that somehow we're wasting somebody's dial-up bandwidth still because that's how the older folks of us grew up. But it's really helpful to be vocal when saying, yeah, I think this is okay. Or something simple like +1. That is a very valuable input just as much as I think this is wrong for X, Y, and Z. And so to the extent that people are willing to start doing more +1s, that will be more helpful in having things move more rapidly. Because when we have a better sense of what real consensus is, we have more confidence on making changes. And without kind of that positive reinforcement, things tend to not change and get paralyzed instead. So that's my soapbox. Also, if you're eligible at all to vote, vote. If you're eligible to stand, go ahead and stand when it's time to run for an election, or it's time to, not even for just core elections, but when we're trying to find people to stand up on certain teams. If you're younger in the community and you may feel uncertain about, kind of less confident about, for example, you're not sure of everyone who's running for core, and so maybe you feel like, well, I shouldn't vote at all. It's much better to vote for 3 or 4 people that you have confidence in than to vote for nobody and kind of do a partial vote. So do that. Do at least some rather than none. And it comes down to any time when you're kind of offering to do something. This part about where change doesn't have to come from core. If for folks who are newer in the community, you may feel, well, I don't really have enough kind of cred or something to like kind of push for something, so I'm just going to kind of sit back. Don't sit back. If you really do something crazy, you'll get some you'll get some pushback. But if you're not getting pushback, probably we're just not all +1ing, and so you should kind of charge forward. So I think that's all the farewell kind of thoughts we have at the end of our term, and we want to give what remaining time we have for questions. And I don't have to answer all the questions since I've been talking for a while, so we'll feel free to hand the mic around.
This isn't so much a question, but kind of dovetails with the vote. After the pizza thing tonight, I'm going to host kind of a BOF for Bylaws 2.0. So if you're interested in that, come see me. John mentioned several of the problems with having a large core team, and maybe that's something we should talk about.
Well, and don't just come see Warner. There will be a group discussion, and you should actively participate.
Oh yeah, this isn't me presenting. I've got 2 slides that have like 4 bullet points. It's going to be real quick if I just sit there and read it. And I'm hoping that I get active feedback, particularly people that disagree.
+1.
Thanks, Pavel. All right, so how are we on time? Because I have no idea. Y'all are supposed to go at 10. So 10:15 is when I think the next slide is? Okay, so we have some time for questions. So don't be bashful.
Can you guys comment on why were so few candidates at the beginning? What was the reason, or what are your thoughts about that?
So few which?
So few candidates. So few people.
Oh, candidates for core?
Yeah.
Haha.
Certainly not new as a phenomenon.
Well,
It was more, are we actually getting 9 people to vote for?
all right, so I'll give my graybeard view a little bit. I don't have the number in front of me. I think if you looked at the last, I don't know, several elections, maybe 10 years worth, you probably would see an overall declining trend in the people who stand. I can certainly remember elections where we had 20 plus people standing for core. And I know Ed has some things he might want to say. You want to go first, and then I'll agree or disagree?
Yeah, I think the general general way that the number of people running for an election goes, we tend to, it's very close to the deadline that people submit their candidacy. So I think it wasn't at all unusual that we had a lower number of candidates earlier on in the nomination period, and then it grew at the end. That's completely normal. I think there's a few things that just sort of all coincided to reduce the number of folks running this time around. In particular, we only have 2 incumbents running, which is a little bit unusual. There's a few reasons that many of the current team members are not running again, myself included. One, we talked in the past about a rotating, trying to introduce a rotating third of the team getting elected every year rather than re-electing everyone every 2 years. And a number of folks on core follow that, effectively a self-imposed term limit. And so that's the case for me, right? I've run for 2, or I've been on the last 2 core teams, and I'm taking this one off, and then will presumably run again in 2 years. And then there's also just some life events in various people's that have caused various people not to be able to dedicate time to it again this time around. So I think that's my perspective on why we don't have a lot of incumbents this time. It's just sort of a coincidence of different factors. Benedict or Wen?
Yeah, so the positive thing that I saw is that more ports people are actually now running for core, not just source people who in the past were more, I know source, I can hand out source bit this way. We're now seeing more ports people and a few more docs people, more that I would have probably seen. But yeah, I like this trend that's not just a team for that particular group, but also consisting of other teams that are also providing a lot of value for the project. So I hope that will continue and also increase, that we have a very balanced core, ideally 3 people source, 3 people source, 3 people ports and 3 people docs. It's not always that way, but at least they provide their own insights, and we have that this year with Baptiste or TC Burner and some others that are also providing their viewpoints from ports that we didn't have in previous cores.
Yeah, and the follow-up is, it's very good that the Baptiste and Tobias, they are bringing many existing ideas and the rules from port manager team to core team, and we think that's good and try to apply. And another thing about the nomination period is longer this year. That was because when the first draft of the election schedule came out, we got a feedback that it's exactly the same as vacation, national vacation in Europe, and there was a concern about if the people want to run for core, have no time to submit the statement. But it turns out that it probably doesn't affect that much. So things might be changed in the next election, but that's the task for the next core team.
So I think keying off one thing that Ed kind of mentioned, we do have fewer incumbents this time, but also if you look at the slate of candidates running this time, I would say we have fewer of the usual suspects. So many folks who have run for core in the past are also not running this time. I think some of that comes down to the fact that the last, I would say, 3 or 4 core teams have been, for unrelated different reasons, more drama than typical core teams. And that people who are on those teams are more burned out than usual. And I think that caused, so for example, I think this time we have 2 incumbents and Alan is running, who's a previous core team member. I don't know that anyone else, unless my memory fails me, who's running as a previous core team member. Oh, Sato-san. So yes, sorry, Sato-san. But a lot of the candidates who are running are not. They're brand new folks. And normally we would have a mix of folks who are new, and we'd have a mix of returning core members. And I think the gap that we kind of have this year is we have far fewer former core members running. And I think I would attribute that to kind of some of the drama and burnout and things that happened over the last 3 or 4 terms, which just have various sources, whether it's personalities that were in previous core teams or specific issues that were dealt with. I know for folks who are on the teams that dealt with code of conduct, that was a pretty draining exercise and that burned out a lot of folks. So things like that, I think, and I don't foresee that being a continuing, ongoing exercise. I see that as a kind of somewhat of a temporary blip for the kind of a run of 3 or 4 teams that we've had that just had some blow-ups. And I think eventually that will pass as folks get a little more time off and recoup, and they'll be back to doing things. And if we can have fewer family emergencies, which, one has limited control over such things, and when they line up, that will also help. Those are not a constant thing, but sometimes they cluster. So I do view it as more of an anomaly. I mean, I think there's a bit of a trend, but I think in particular this year it's just kind of a bit of an anomaly as opposed to the definite future going forward.
So one of the comments that I got from somebody that ran in the previous one, but not this current one, was that historically, when the votes happened, they listed all the votes,
Yep.
both the winning and losing candidates. And last year, they only listed the votes for the winning candidates, and the losing candidates didn't know where they stood. And he said, I ran. He was a relatively new committer at that time, and I had no idea where I came, and so I just didn't feel like it was worth going through all the effort. And if I had, known that I was like within a few of getting it, I would have run this time, but I just couldn't get myself motivated to do that.
Nope.
So
Yep.
the takeaway from this is please list all the votes, whether
Yep.
you got in or not.
I definitely, I think that's very useful too, because it's, as an incoming core team, there's a sense of some folks have more mandate than others, to be very frank. And it's kind of good to know that in terms of how the community feels.
Yeah,
If I remember correctly, the public announcement sent to the announcement list only lists the elected members, the statistics of elected members. But if you log into the election system, you can see the full result. Yeah, so that means a candidate who is for sure eligible for vote, they can log into the system and see the static of themselves.
in the past, we've also, not this past time, but we'd also sent it as an email for the announcement to the developers list.
Yeah.
And that was different
Yep.
this last time. I would change it back to the old way.
I think I even emailed and said, can we please fix it? And it maybe didn't happen. But yeah, we normally send the whole thing to developers because not everybody will go back and log into the system, but the email is pretty easy to see and low effort to get all the data in the email versus then having to go back and log into a system with a password you'd never remember. So. Oh, well, someone who has the, oh, that's true. I guess someone could have copied and pasted. I didn't even think of going and logging into Get It and copy and pasted it. But.
So I'm going to amplify a little bit on the burnout. Publicly, my reason is my daughter's graduating. But I was on the fence because of the burnout from my last time on core. And I still don't know how to talk about that or how much I should say because it was personality driven and some of the personalities are gone and I don't want to be unfair to them, but I also want to voice that there wasn't a good mechanism to deal with that. So I don't, it's hard to give good feedback to people because you want good candidates, you don't want to scare them off. And at the same time, there is, some amount of, respecting other people enough not to complain too much. And I'm channeling that into the bylaws thing tonight. But that's also something that's been going on because the last couple of times people have sent email to the list, hey, why isn't anybody running? And everybody on core is looking at each other like, do you want to tell them? No, I don't want to tell them. So we need to find a more functional way of dealing with that, and I don't know what that is. So I just want to voice that because you know what I'm trying to say.
I will walk slightly further out the limb in saying that it is not a helpful, and mostly not helpful property to come into core deciding that you want to blow things up and burn everything to the ground and build from scratch. that mostly that doesn't be productive and doesn't turn out to be helpful.
Because the things you blow up are people.
And there's reasons the things are there oftentimes. Some things evolve over time, and there's not always, I mean, there's history, and sometimes it's because it's what it ended up working, even if it's not perfect. But yeah, going in with the mindset I'm going to burn it all to the ground and blow it up has a wide blast radius.
It burned down our X11.
All right, that horse is kind of dead. How are we doing on time? Is it okay? So let's do like one last question, because then I've got to hand it over to folks from the foundation and make sure they have time to do what they want to do. No more questions? I'm fine. Okay, Alan.
Especially with so few incumbents this time, how are we going to ensure better handover from previous core to next core? Because on my previous terms, that's always been a problem. For example, with the code of conduct, there was a lot of information that was not passed along.
So that's a good, fair question. We are trying to write up a specific document about things we think are worth noting for a handover. One bit of advice I will also give to the next core team: do not take the current agenda as a starting point. Throw it away. We will give you some things that you may wish to, that we think you might want to add to your agenda that you create from scratch, the things you want to do, and that will be kind of the notes document we give you. But otherwise, don't look at our stuff, because everyone gets mired with things that are hard problems to solve that have been around for 20 years that we're not solving. And like, oh well. You're better off picking a list of like 3 or 4 priorities, well, 3, that you want to work on as a team and kind of have that be your focus for your 2 years. And then part of it is you have to leave enough margin for the fires and emergencies that come up, because everyone has their list of priorities, and then we have the issues that must happen right now that keep popping up and robbing your time that you have. But we will try to be diligent. We'll certainly have a meeting with old and new core on like a video call where we will talk about things. We can probably do more than one. Personally, I will also be always happy to talk about stuff and relate whatever history is going on behind things that you might inherit. I know I'm not running this time because of family reasons, but I'm trying to conserve my time to some extent, but I'll be happy to talk with anybody from Core 12. That's probably true of other members, but I will be available. Okay, well, let me hand it over to the foundation folks, and I gotta get their slides started.
Grab us up first.
Update from the FreeBSD Foundation. from Deb, Joe, and Ed. So Deb, are you going first?
Sure, yeah.
All right.
Okay.
You, Deb.
Okay. Okay, is this working? Can. Yeah, that's. Yeah, should I put it maybe up higher? Okay. Okay, can everyone hear me okay? Yay, okay. Hi, everyone. I'm Deb Goodkin, and I'm the Executive Director of the FreeBSD Foundation. And welcome, everyone. It's so nice to get out of my home office. I mean, I love my home office, but it's great to get out and be with our community and see people in person. I know people are live streaming. I think people are live streaming. And so welcome to folks from all around the world who are here. So we have 15 minutes to talk about the foundation, what we do. And so I'm going to take the first 5 minutes and actually, well, I started the timer, and talk about just like an overview of what we do. I know most people here know what we do, and I recognize almost everyone here. But one thing that we did learn from the survey, and I was going to go over our takeaways and sort of our insights too from the survey, but we didn't actually have time to do that, and since we don't have a lot of time here, I won't do that here. But there are some key things that I did want to highlight, and so one thing was just the fact that people just aren't familiar with what we do. One thing that came out of the survey was just that folks knew that we did advocacy and legal, and it really was surprising to me just because we do spend a lot of money and our resources on software development, and so I just want folks to really to know that, but it also highlights the fact that we need to publicize what we do more, and so I know folks here know, and there are some new folks too, so that's why I want to make sure that folks or attendees are aware of the work that we're doing. And other takeaways are just helping new people navigate the process on how to contribute. So we're looking into helping with that, and hardware support came up, and surprise, surprise, Wi-Fi. And that's something, I mean, we hear you, and we've been working on that. And Ed will cover that, and Joe. And so anyway, so I'm just going to give a really quick overview, and then Ed and Joe will talk about what we're doing in the technology group. And so just to remind everyone, we are a US-based nonprofit, and it means we're for the public good. We're 100% funded by your donations, and so we always ask you to help us, ask your companies to help fund our efforts. And then our whole purpose is to support the FreeBSD project, and you are the community, and you contribute in so many different ways. So what do we do? Just really quickly, we do software development, fix bugs, implement features. We advocate for FreeBSD. We have folks on the security team. We have Lee Wen, who heads up the continuous integration. We do purchase almost all the hardware for the FreeBSD infrastructure. Work on partnerships, do market research, understand what users, how they're using FreeBSD. We are the legal entity for FreeBSD, and we do organize and plan and run events just like this one. This is who we are. About half of our team are here. Just to highlight, Ed is our head of technology. Greg Wallace, who's over on that side, he's heading up our partnerships and research. And then Kim, who's not here, is heading up our marketing and advocacy work. Our goals, just really quickly, increase adoption of FreeBSD. Also make sure that current users are continuing to use FreeBSD, to be able to use FreeBSD on your desktop. And so we are using the example of a college student being able to use it for a whole semester. That will benefit almost all users. Increasing the visibility of FreeBSD. One thing we hear is that we don't hear about FreeBSD. I mean, we hear this from all over, and so this is an area we're investing in raising $2 million. If we can raise at least $2 million, we could continue the efforts right now, what we're doing, filling gaps, and we could fill in more gaps if we raise more money. So I want to discuss increasing advocacy and visibility. And the reason why I'm doing this, so there's 2 key areas that we're going to focus on today with our short time. So it's marketing and it's software development work. And the reason why I want to talk about marketing is because I know we're at a developer summit, and there was an informal survey that went out late last year from Core. And so one thing that stood out, and I don't know how many people said this, but one thing I heard was, we're at a developer summit. We want to hear about technology and improvements in the operating system. We don't want to hear about marketing. And so I totally get it. I mean, my background is engineering, and so when you look at things in a, with your own lens. But I'll tell you, it's so important that we advocate. We like to refer to it as advocacy. We are doing FreeBSD advocacy for you, and we are promoting your work. And so by doing this, we are enabling technology by so many different ways that I've thought of listing right here. So I'm going to talk a little bit about what we've been doing to improve our advocacy efforts and to improve the visibility, and with the goal of increasing the adoption of FreeBSD for all different types of use cases. And so we've started interviewing users, and so we have a YouTube channel, well, the FreeBSD YouTube channel that we're posting them on. And so this is just tracking from this year. So this is just sort of starting up with the new resources that we have on staff. But one thing I do want to highlight is down at the bottom. I don't know if you can read it, but we're starting to see these comments come over, like the different forums where we're posting these things. So it's like, thanks Tara and Kim, keep up FreeBSD evangelism. We've been needing this for years. So we hear this, we see this, and we're starting to do something about it. Commercial use cases, we've just published, we actually have 8 now. On our website, we have a new updated page. We combine the testimonial page. And now what we're doing is we're sharing commercial users' stories. And so it's helping show other users and corporations how companies are successfully using FreeBSD. We have some of the views. Netflix had the most, almost 10,000. Well, actually, these stats are up to through April. So it's, I'm sure all of these have increased now. And we want your story. So if we don't already have your story and you're willing to share it, please let us know. We have a writer on staff. He's also a journalist, and he's excellent at working with users, with companies to get their stories and really present it in an interesting way. We've been producing content. We have writers on staff now. And not a lot. I mean, it sounds like we have a big staff, but our goal is to produce high quality content that really resonates with business decision makers, the people out there who are making those decisions on what operating system should we use, and understanding that FreeBSD is a compelling choice for their use case. Right away when Jason stepped on board, he actually met or interviewed Colin, who is our release engineer, and wrote blog posts on those releases that came out, and also wrote a story on Colin and the process, and also thank Glenn for all of his time being our release engineer. And then social media, we've improved the strategy. We are posting more. We're getting a lot more engagement and views, and just posting more like exciting and engaging, informative content. And so the graphs are just showing the growth. In this case, it's the impressions. And so people have been showing us some of these comments. I don't always see them on these different forums. But I mean, it's just showing like, nice to see BSD getting decent press. And the foundation has stepped up, up a gear lately, and it's good to see. And so I'm not trying to pat our backs on this. It's really to showcase or to highlight the fact that we weren't advocating enough, and that's something that the project really needs, and that's what we're doing for you. I want to cover a little bit about partnerships. Okay, I have 1 minute. I will not be able to give this, this topic the justice it really deserves. But we did bring in Greg Wallace, he's sitting over there, as our head of partnerships and research. I know a lot of you folks have met with him already, but it's giving the community a chance to have someone who's really focused on what you're doing. If you're a commercial user, or even not just, but an individual contributor too. And so he's meeting with companies, find out what are your use cases, what are your challenges. He's also selling FreeBSD, and this is part of the advocacy. They're helping provide that content. Also connecting folks within the community with these corporations. He's identifying opportunities. And so some of these things that I've listed, I'm actually gonna let Ed and Joe cover. And then identifying needs of our users and actually heading up new groups like the Enterprise Working Group that I think a lot of you are familiar with, and it's connecting people and also having a chance to hear what are your challenges? What are the issues you're running into? And it feeds into what we're doing, and it helps direct the work that we're gonna do. And finally, the other thing is that he is actually providing a voice for us in these government discussions on on cybersecurity. I mean, that's the big thing right now. And so being an active participant, representing FreeBSD, and sharing how we're doing things, as well as finding out what are these mandates and guidelines? What do we have to do, or what should we do? And bringing that information back to the project. So with that, I'm going to hand it off to our technology team, and Joe will kick it off or take over. And one thing I do want to say is please vote. And one more thing, too, I want to piggyback on what John said, is that please consider, if you've been around for a while, to mentor new young people to our project. And I've really seen this work where young people will join, and they have that excitement and enthusiasm, but they feel like they see all of us. And they're like, well, I don't have the years that this person has, and I can't mentor a GSOC student. And think about how these young people can do it, and sometimes they just need someone to help bring them along. And so we've seen this within the project, but we don't talk about it much. But we've had an example of someone who did lead a GSOC project. He didn't think that he could. He had a great idea. And I said, well, why don't you lead it? And he said, well, I can't. I'm too young. And so we actually convinced him to do it. We got a mentor for him, so a mentor for a mentor. And it was highly successful. So I really encourage people, when you see new people, especially here at the conference, to start a conversation and find out what they're interested in and see what you could do to help. Now, I will hand this off to Joe.
Okay, so I was asked to take about 5 minutes just to tell people, update people on what the technology team has been up to for the past year. And I thought I would start with a very rough but simple way of showing what's been going on, and that's with commit data. So the donut plot on the left is a breakdown of all sponsored commits to the source repository, which makes up about 43% of all commits to the source repository. So I presented this in the past 2 updates, and nothing has dramatically changed. The foundation is still the biggest contributor to sponsored commits. It's also interesting to note that the Foundation and Netflix together make up about half of those commits. And maybe the other takeaway is it's nice to see lots of colors there and that lots of different entities are contributing, and I think that's healthy. I mean, it's good and bad that the Foundation and Netflix are high in some ways, but it's also good to see it's more sustainable, I guess, if we see more entities contributing. The column chart on the right is a breakdown of the Foundation-sponsored commits over the 3 repositories over the past year. We typically focus on sponsoring work in the source tree, and that's stayed pretty steady where we hover around 100 sponsored commits per month. The spike there in the ports tree was when we contracted Moin Raman to deal with ports fallout related to LLVM and OpenSSL v3 updates in preparation for 14.0. And so I'll say, we have very limited time, so I'll say very quickly about what people are doing on the technical team at the Foundation. So everybody knows Ed. Ed, of course, leads the team, and he does a lot of direct development work, but he does a lot of things behind the scenes. So he does a whole lot of work with Greg on partnership stuff, partnerships with companies, does a lot of mentoring, serves on core, all those sorts of things. Konstantin is using his x86 operations expertise currently to work on a project to develop an AMD IO MMU driver. Lee Wen does a whole lot of things behind the scenes too, like he does a whole lot of mentoring, a lot of high-profile projects like CI, Git conversion, commit bits in all 3 repositories. As a project manager, I support developers who work with the Foundation. I try to chip in other ways like administering Google Summer of Code, sometimes mentoring, and I try to sneak in a bit of ports work when I can. Pierre Proncheri's face might not be as familiar. He's still somewhat new with the Foundation. He came from NetBSD to work on userland tasks, so he chipped in a lot to update OpenSSL to v3, did some work on the installer, is now doing some security work. These are what we're calling our long-term contractors. So Mark contracts with a lot of different entities. He's also worked with us for quite a while. And Mark also does a lot of things behind the scenes that people may not be as familiar with, like a whole lot of mentoring, which is great. Bjorn has worked in a limited capacity with us, but over a long time on wireless stuff. Made a lot of, a big push recently for some stability improvements in wireless. So hopefully everybody that's running FreeBSD had no issues with wireless here. I haven't heard any complaints yet. Mitchell will talk later about the RISC-V work that he's been doing. John is basically on call for us for security issues as they come up. Olivier, still relatively new with us, touches a lot of different parts of the tree. Right now, a big project that Olivier is working on is to make UnionFS stable and useful on FreeBSD. Tom, I listed Tom as networking because he is wrapping up a project to port VPP, vector packet processor, to FreeBSD for RGNets. And these are project contractors who are either working with us now or completed a project within the last year. Robert Klausecker implemented SIMD versions, single instruction, multiple data instructions for a bunch of libc functions with the goal of improving performance. Kirk finished at the end of last summer a project to enable snapshots on UFS with journal soft updates. Moin has a couple different projects with us, improved CI, did that ports work that I mentioned. He's also working on a CIS benchmark, which is essentially a guide for securing FreeBSD by default. Mina's working on Cloud Init. Pablo, who's here, is wrapping up a project to add hierarchical rate limits to ZFS. Christos, former GSOC student, worked with Mark on a bunch of different projects. He's working on improving audio on FreeBSD right now. Philip, long-time cluster admin member, does a whole lot of work for cluster admin. He basically set up a new cluster site in Chicago and will be working with us to continue that work soon. And Cheng assisted Bjorn for a project for 6 months on wireless tasks. And so we have some people I think that are here. So Li Wen mentors a lot, as I said. So Yan Hao and En-Wei both worked with Li Wen, so on docs and testing. And En-Wei gave a talk here at BSDCan on his wireless work, quite a nice talk. Naman and Jake both interned with us. And Chixin is doing a whole lot of work. Oh, he's here, great. On OpenStack outside of his regular job. And then Sala is going to start working with us 10 hours a week to improve desktop experience. So implementing some of these dbus daemons that are required for desktop environments. And last thing I'll mention is that we've had a long-term relationship with Google Summer of Code. We participated every year, 274 total projects. I think the biggest benefit, in my opinion, from GSOC is introducing new people, young people to the project. So right now, we have a core team member who was introduced to FreeBSD through GSOC. Not all projects make it. GSOC projects have code that make it in the tree, but some do, and here's a couple examples. And we are participating again this year in GSOC with 11 projects. Don't have time to say anything about these, but if you just search FreeBSD GSOC, you'll find descriptions of all these projects. And I think now Ed is going to talk about kind of bigger picture topics with projects.
I'm going to go through this quite quickly because we are well into our break, and we want to make sure that there's a little bit of time for folks to have a break. This is a very high-level view of sort of the criteria by which we might choose to invest in a project. So we'll find things that have a broad appeal to the community that will benefit a large portion of our users. We'll find things that the community is not taking on within funded development efforts from within companies. So a lot of developer tools and general usability things, everyone kind of wants it to be there, but it's not something that is necessarily of value to a specific individual company to invest in. Things that Deb mentioned very briefly, foundation goals for 2024. And so tasks that align with those goals will be things that we fund. And then just sort of general projects that are important to FreeBSD's viability as the technology landscape evolves. And so the work that Caustic is doing right now on the AMD IOMMU driver is something that's sort of just, it's a necessary component for FreeBSD to continue working on hardware that's becoming available. And so I have a few slides here that basically talk very briefly about projects that we are evaluating. We're looking at scoping. We have proposals in to invest in, but they're not sort of necessarily committed yet or haven't been discussed publicly. In all cases, some of them, there's things that have been done, and I'll mention those briefly. So Framework laptops, we've had some initial discussions with Framework to use Framework as one of the laptop brands that we're going to, within the foundation, highlight as a preferred laptop, or within the foundation, we're going to work with Framework to make sure that Framework laptops work well with FreeBSD. The graphical installer, Joe mentioned briefly, Pierre did a lot of work to take our existing installer and port it sort of in the same form that it's into a graphical installer. And I think one of the things, I mean, I've heard feedback when people have looked at this project, in sort of two main themes. One is, I'm glad that someone's finally doing this. We're moving out of the 90s finally. And then I've heard, we can't get rid of a text installer. FreeBSD like this is what we are. We can't eliminate the text installer. And I think we're not looking at replacing what's there right now, and the installer that Pierre has worked on is the same installer, the same workflow for better or worse, but is it's a starting point for us to look at what might be possible. And right now we can do the exact same workflow that we had before in text mode or in starting from in graphics mode right at the beginning. We're looking at a few things with to improve the boot story, interacting with projects like netboot.xyz and Ventoy, which is a multi-OS tool that's really popular for people who run lots of different operating systems on their laptop, people who are sort of cycling through and trying different OSs all the time. And so I think it's really important that FreeBSD interacts well with those sorts of tools, so that the people who are trying 5 or 6 different OSs, FreeBSD is very easy to install in that environment, rather than being, oh, I can install 17 different Linux distros and all kinds of different things, but FreeBSD doesn't play well with that. Wi-Fi is an ongoing source of frustration for many, and we're going to continue investing in Wi-Fi and finding additional ways to try and move things faster if possible. Sound subsystem, Joe mentioned, and I think we have a lot of good work that Christos has done so far, and Christos's plan has additional work with things like Bluetooth audio integration, making that sort of work out of the box in a more convenient way. And so that fits very much into what Deb was saying around FreeBSD being usable as your development environment if you're a university student, say. And so the developer workflow, your editor, your compiler, those sorts of things work well on FreeBSD, but we also want to make sure that, if you just want to listen to some music while you're coding, the basic things like Bluetooth audio just sort of work. And all of the pieces are there in FreeBSD. I mean, some of them are a little more or less fragile or in different sort of different states, but it should be straightforward for people to use basic things like that. Looking at, along with what I mentioned earlier, sort of integrating better with dual boot environments, so people who want to, again, want to try multiple different OSs on their laptop, it should be easy for them to do so. A few different projects that we're pursuing in multiple ways. I think Lee Wen has talked a bit briefly about the webcam driver, but we're looking at a couple of different ways to make sure that standard USB webcams are well supported. We're looking at package base, stepping in to kind of clean up whatever loose ends we can help with, and then also, along with what Joe said earlier about the Foundation's focus being fairly source heavy in the past, we're looking at trying to invest more heavily into ports looking forward, and so picking up some things to help support ports infrastructure in general, and CI in particular is something that we're looking at. And then a couple of things that are somewhat more aspirational or under investigation. There's been interest from a few sources of using the Octo tooling and ecosystem, but to build FreeBSD. And so I'm not entirely sure if this is something that will come to fruition or not, but it is definitely something that's under investigation. Within the Foundation, we're looking at how we might collaborate more closely with Cherry and Armorello. Basically, there's a lot of research and a lot of work that's happening in an academic context, but we're interested in seeing from the Foundation's perspective how we can kind of help move that whole ecosystem along, and what we can bring in our unique way to support that. We've had some discussions with various folks on making what's sort of the de facto standard GPU and AI approaches available in FreeBSD. And so again, as with some things I mentioned earlier, a lot of this is possible in FreeBSD today, but rather awkward or cumbersome. And so as a very first step, we're looking at just trying to make things streamlined a little bit and more usable. And then finally, a couple of language runtimes that are interesting or important for various reasons. So .NET and OpenJDK we're looking at trying to support. And then from feedback from the core team, funding work on an iNotify or equivalent infrastructure and implementation in FreeBSD is something that's high on our priority list, and that's what I have. So I think that our break is going to rapidly run out. So I'll hand it over to John to take on. Thank you.
Thanks, Ed and Deb and Joseph. So I've negotiated with Mark that he'll start about 5 minutes late, so we can still have about a 15-minute break. So let's be back in here about 5 after the hour, and I'll give Mark time to play with XR and R before we start again. Thanks. So if we can make our way back to our seats. I got a good thumbs up from the back, so I think our AV stuff is all working. Yeah, +1. I guess it's our theme for the summit this year. Okay, so our next talk this morning, as we all keep getting to our seats, is from Mark Johnston, talking about some really cool stuff he's been working on. Oh, and I see a panic. Isn't that fun? But I'll hand it over to Mark and let him introduce his talk. 2 more minutes? Okay, so I'll do a song and dance. I'm not a good Bugs Bunny. Yes. Yeah, I won't do this if you pay me. All right, so are we on like T-1 second? Okay, I see bouncing T-muxes. It's a perfect demo. Okay, I'll let Mark get started. You can introduce and then
Sure.
debug as you go.
Okay. Yeah. Is it just not? Am I not speaking loud enough, or is it?
Could be. Or get a little higher on your shirt.
Yeah. It's okay.
Yeah, actually, that side works.
How's?
Turn and face the screen more.
Yeah. Okay. Is that? Can everyone hear me? Okay. Okay. Sweet. So apologies in advance. This panic is actually expected, but in order to show you more, I need to SSH to a system at home, and my apartment is going through a hydro switchover today, so they shut off power, I believe. So anyway, that's fine. I have a couple of things to show. So hello, everyone. My name is Mark Johnston. I'm a FreeBSD source developer for 12-ish years now, mostly working on the kernel, but really working all over the place. And so for the past while, I've been thinking a lot about how to make FreeBSD source development more effective, more efficient, to give people more confidence when they submit patches. So especially for new contributors, you write a patch for FreeBSD. How do you know that it's not going to break stuff? You can boot it up on one of your computers. You can do all sorts of things, but there's no real, in my opinion, there's no kind of universal tools that you can use. Everyone is kind of left up to do their own sort of thing. And like I've overheard conversations even this morning. People write their own scripts to build VM images to test. So I wanted to present a tool that I've been working on for the past month or so, but I've been thinking about for a lot longer than that. And we'll go through that. But first, a bit more motivation. So like I said, FreeBSD source development is almost uniquely challenging. You're developing a whole operating system. So there's a kernel, there's hundreds of utilities, there's libraries, and then that's just the base OS. If you change something in the base system, you might break ports. It's hard to know. So there's a lot of sort of intrinsically complicated aspects to FreeBSD source development. On top of that, we have lots of different configurations. You might be running on ARM, x86 64. Maybe you want to test with a particular custom kernel config. There's huge numbers of combinations of system configurations that you might want to test. And it's, again, kind of painful that we have no canned way to actually deploy FreeBSD. In the ports tree, we have this tool called Poudriere, which is very, very useful. It handles all the automation needed to kind of build ports in a sanitized environment. It sets up jails for you. It creates ZFS data sets. It does lots of caching of build artifacts. It's just a very kind of handy one-stop shop for anything you might want to do in the ports tree. So I think source is more complicated. There's a lot of different things one might want to test. But for a long time, I've really wanted to have a universal tool that all developers can use in a fashion similar to Poudriere. When you're testing a change, here's some baseline things you can do that are very easy, a single command, and you get some results. It might take a while, but that's OK. So for folks who are familiar with CherryBSD, there is actually a tool that kind of approaches that called CherryBuild. I won't talk about it too much, except that it's I've stolen some ideas from it, and it kind of approaches what I want. It's effectively a very large Python script, which has canned recipes for building all sorts of software that are used in the Cherry ecosystem. So I won't go too much more into it than that, but in order to boot Cherry BSD, you need to have a special tool chain, you need a special QEMU, you need all these kind of tool chain components. So Cherry build is a script which will sort of marshal all of that with a single invocation. It's very, very convenient. So when we're trying to test kernel changes, I personally make heavy use of virtual machines. Both QEMU and Beehive are very useful for that, especially for kernel development, just because rebooting hardware takes a long time. It's hard to automate. So I tend to leverage virtual machines quite a lot. And I think as far as kind of getting a baseline, pre-commit, CI, whatever you want to call it, some kind of test regime that is more involved than just building a kernel, I think VM images are really useful. So right now, we don't have this sort of single blast way to build VM images. There's make release, which currently requires root, or at least it did last time I checked. That might not be true anymore. But it has various limitations, and those will maybe be a bit more apparent a bit later as I go into examples of the tool that I wrote. But what it effectively means is that downstream CI systems of FreeBSD have to reinvent their own solutions a lot of the time. So the Jenkins builds, have their own scripts for building VM images. I have my own scripts. I'm sure a lot of other source developers do, and so on. So I wanted to be able to automate. So in much the same way that you can kind of do test port builds with Poudre, I wanted to make it kind of easy in the sense of having a single command which does everything for you to run the regression test suite. Other test suites that we have, so there's one called Stress2, which is really useful for some types of kernel changes. There's a system called Fuzzer called syscaller, which is really useful for testing, again, certain types of kernel changes. All these things today take a lot of effort to set up. There's no sort of blessed tools for that. So yeah, just to demonstrate how challenging it is to actually run the regression test suite today, if you wanted to, you need about 20 different packages. I can show you the list. It's hard-coded in a few different places, but yeah, the list is right here. So just to run the test suite on FreeBSD, you need core utils, Python, some other Python stuff, Perl, KSH. And that knowledge isn't encoded anywhere. You just have to run the test suite and see which tests are skipped because we don't have certain things installed. Go and install them, run again, and figure it out like that. So hard coding it here is not the best solution, but having it in kind of one tool that knows how to do everything so developers don't need to figure it out over and over, I think is a useful step forward. And similarly, to run the test suite, you need a whole bunch of kernel modules loaded if you want to get all of your, if you want to kind of test everything. So similarly, if you want to test PF, you need to actually explicitly load PF, otherwise all your tests will be skipped. It's not very nice. Yeah, so, and one of the other goals of my tool is to be useful for both interactive and CI environments. So if you're developing something, you want a really tight feedback loop. You want to be able to build and test and get some results, and then edit, compile, test again as quickly as possible. So you can, do other interactive things like attach a debugger to a VM without having to figure out where the path of the kernel is, the path of the kernel symbols are, which port the GDB stub is listening on. All these kinds of details are not really important. But at the same time, it's a script. It's got a command line interface. It's very regular. You can do a lot of things with it in the sense that once it starts running, you can just kind of leave it alone and watch the output. And you get a result at the end. So my attempt at this is a script called Bricolage. In the fine tradition we have of naming tools after French words, bricoler is a French verb, which I believe means to tinker, basically to play around with, to experiment with. I don't think it has any negative connotations, not that I found, but if it does, please let me know. It's just a name, I don't know. It's a Lua script. It tries to have very few dependencies. So it actually wraps a whole bunch of system calls and libc functions, and that's it. Oh, and it uses a library written by Kyle Evans, which kind of provides an expect-like interface, except it's all done in Lua, so it's a bit nicer to integrate. That's called orc, which I believe is short for orchestrate. So that's it. So when you download the repo on a FreeBSD system, just type make, and it'll do everything for you. So yeah, you just need Lua 5.4 and CMake. And then some of the things you might actually do with it will require other packages. So Bricolage is just a little framework that's a bit more structured than having a bunch of shell scripts which do different things. So the idea is to have a bunch of reusable units of work that you might want to execute during development. And those are called tasks. But in general, that would correspond to me to like a single script. So for instance, I have a task which lets me run the FreeBSD regression test suite against a FreeBSD source tree. So there's a few subtasks involved there. You have to get a copy of the FreeBSD source tree or update the existing one. And to do that, you need to know which branch you want to pull from, which repository. Maybe you don't want to actually clone it. Maybe you just want to use an existing clone that's already somewhere in the file system. So there's a whole bunch of parameters there already. After that, you need to build a VM image. So you need to run build world, build kernel, install world, install kernel. And you might want to inject various source.conf options. You might want to set a custom kernel config. Yeah, there's, again, a whole other sort of set of parameters there. Then you need to actually build a VM image. So first you need to build a file system image, usually either ZFS or UFS. And you need to make a disk image out of that. So again, a few steps. And then you need to actually boot it. So again, which hypervisor do you want to use? How much memory do you want to give it? How many CPUs? There's all these parameters that you might want to adjust. So doing all that with shell scripts is pretty painful. When you, we use a lot of shell and make-based tooling in the project. And I think that's convenient, but it's not very friendly. If you mistype a variable name in your command line, usually, there's no checking for that. Like if I type kernconf instead of, if I skip one letter in kernconf, it's just going to build the default kernel, and I won't know unless I check. So that's not nice. And that's one of the reasons I use Lua instead of shell. So all of these 4 tasks: getting the source tree, building FreeBSD, building a FreeBSD image, and actually booting a VM. Those are all tasks in this framework. So for instance, I might want to boot a VM that runs the regression test suite. I might want to boot a VM image that just gives me an interactive prompt. Maybe it runs a different test suite. Maybe it does some custom thing. The whole point is to not, write the same code over and over to do that sort of stuff. So to give one example, maybe I want to build a VM image and boot it interactively, but I want it to be an ARM64 image, and I want it to have a KSAN kernel, and I want the root file system to be ZFS, and I want Emacs to be pre-installed for some reason. So that's the sort of thing I can do. And then, I want to attach a debug to the hypervisor. I don't want to figure out which port it's listening on. I don't want to figure out where the kernel is. I just want it to work. And one of the other requirements was I don't want it to use root privileges unless it really needs to. So in particular, right now, if you run it with root privileges, it'll give you an error. That's probably a bit too strict because you might want to use it in a jail. But the point is that you might want to be able to run this on some shared system where you don't have root privileges and still get some utility out of it. So in the FreeBSD cluster, we have systems that are used for building FreeBSD. And they have QEMU and they have everything you need installed, but you don't have root. So I want to be able to use this framework there. I've been working a bit on getting unprivileged Beehive to work. So I have some patches which add like a device interface so that you can create and destroy VMs. Right now you need a syscontrol to do that, which is why it requires root. But hopefully in the next month or so, I'll have the ability at least, if you want, you can configure your system to allow unprivileged Beehive without certain features like PCI pass-through, but enough to make the rest of this useful. And then I don't know if folks have noticed in the past year or so, I added a new network backend, which is kind of similar to user networking in QEMU. So there's like It's basically like a user space network stack that's good enough to let you SSH into a VM without having to create a network interface, without having to find an IP address, all that kind of stuff. So are there any questions so far? Am I being concrete enough? I'm going to show some demos at the end of my slides, which will be over pretty quickly. But kind of the point of the talk is just to demonstrate my solution at this. I really want this tool. It doesn't have to be exactly like this. I just want something that does these things. So if folks have opinions on what the UI for such a tool should look like, if there's any disagreement or any questions, I'm happy to talk about it, because I'd really like other folks to start using something like this. When you're taking pull requests from users off of GitHub, it'd be really great if you could run it through a tool that just does a whole bunch of checking for you without having to think too hard about it. So that's really my goal here. And I'm not tied too much to this particular implementation, but I really think that as FreeBSD source developers, we really need a better baseline than what we have today. So this kind of ties into the discussions we've had for the past while over pre-commit CI. And here's, again, just my attempt at it. So I'm very interested in criticism. So just some of the basic ideas before I launch into demos. As I said, the sort of basic abstraction in Bricolage is a task. A task is just some reusable piece of logic. Some parts of the task are defined declaratively. So it has inputs, which are the outputs of other tasks. So for instance, there's a task to clone a Git repository. Its output is the path to that repository. There's a task to run FreeBSD make targets, so like build world, build kernel. The input is a FreeBSD Git repository. The output is an object directory and maybe a staging directory if you've installed it somewhere. So that stuff is all declared in a task definition. And just to make it really visceral, I'll show you an example. Well, just going back to this one, there's a task which builds a FreeBSD VM image. There's a whole bunch of metadata. So you can see, just using Lua tables, I can define inputs and parameters. This one doesn't have any outputs, I guess, which is a bit counterintuitive. But anyway, so you can see, for instance, one of the parameters is a list of kernel modules that will get loaded when this image is booted. You can define things like the size of the VM image. You can provision SSH users so that it's possible to SSH into the VM as root. So it'll generate SSH keys to do that. So that's this sort of declarative component. And then there's a function called run, which in this particular case doesn't do very much. Oh, I see. Yeah, because this is actually a derived class. So yeah, sorry. This is the script for building a VM image specifically for running the regression test suite, and it reuses most of the code from the sort of base VM image task. So all this one does is set a couple of syscontrols that you need in order to run the test suite with full coverage, and it'll make sure that certain packages are installed and certain kernel modules are installed. And then, when the test suite is running, it's useful to be able to SSH in and have a look, so you can do that. So the actual implementation of the task is in a function called run. It takes a table as input, which has all the inputs and parameters bound to its keys. So you can use them in your sort of execution logic. Each task, when it runs, gets its own working directory, so it can save its output files there. There's a command line syntax, a sort of uniform command line syntax for actually running a task. And again, I'll show some examples very shortly. Aside from actually running the task, you can do sort of auxiliary things like attaching a debugger to a running VM. You can SSH into a VM. Again, you don't need to know anything about how it's running. It just needs to be running, and then you can run this command that lets you SSH. And so it tries really hard to stay out of your way. And that's really the goal, right? I want it to be easy to use. I want it to be easy, discoverable. So again, if you just run Bricolage run, it'll show you all the tasks it can run. The output is not very nice. I think I need a nicer way to present this information. But you get a name of the target and a little description of what it does. So if, for instance, I decide I want to fuzz FreeBSD using syscaller, I can select that target and then get a list of all the parameters that it takes. And so you can see there's quite a lot, but those are all defaults. And the point is to give you sane defaults so that you don't have to futz with them in order to do something basic. But if you want to fuzz something other than AMD64, you can say, well, so the parameter, I'll show in a sec once I've typed this out. Actually, maybe a better example is, instead of using QEMU as the hypervisor for syscaller, you want to use Beehive. Sorry, I can't see very well. Okay, so here on the bottom, I don't know if folks can see this more or less. The syntax is basically just the task name, and then a colon, and then the parameter name, and then an equal sign, and then value. So if I update the list of parameters on the command line like this, then you can see now, okay, the hypervisor is Beehive, it's set on the command line, and then if I remove that show flag, it'll actually go do the thing. At least it should. It might do something else. I've been mucking with it a lot this morning. Oh, yeah, and okay, so I'm not going to use Beehive because you actually need to do some extra setup for this one. So what it's doing right now is it's going off and building syscaller, then it's going to go off and build FreeBSD, and it's going to go and build a FreeBSD image, and then it's going to go start syscaller, which itself starts VMs. It does things like it'll do incremental builds by default, which I think is the same behavior for pretty much any build system, but FreeBSD does clean builds by default, which wastes a lot of time. So you can see that in the make invocation at the top of the screen, there's a whole bunch of parameters that are getting set. So things like the kernel configuration are custom. You don't have to tell it. Yeah, so there's a lot of noise here because we print a lot of warnings during incremental builds for some reason, but I promise it's pretty fast. So maybe I'll let this run in the background. Give it a few, just 4 CPUs. And so one of the other things I wanted to do with this project is evaluate the use of Lua as a kind of glue language in the base system instead of shell. So we have Flua in the base system. It's used for a few small things, but I think its adoption is held back a bit by the fact that we have no real system libraries for it. So if you want to do things like spawn a command, I think there is now a library function for that, but there's a lot of basic things that are just not there. So a lot of system call wrappers are missing. A lot of libc function call wrappers are missing. And it's not a lot of work to add them, but there needs to be some discussion about what the interface, kind of how to namespace things, what modules we want to provide, how to document them, all that sort of thing. But as part of this project, and because I was trying to create as few dependencies as possible, I wrote a whole bunch of those system call wrappers. So for things like POSIX spawn, make temp, all those kind of classic libc functions, and maybe around 20 or 30 or so system call wrappers for things that I needed. So even things like make dir. So that's been very smooth. I'm really encouraged by how easy it is to create Lua extensions in C. That's not a novel discovery, but for me it was a useful exercise to kind of go through it and see how hard it was. So I'll be really interested for the rest of the conference if anyone wants to talk about Lua in the base system and how to approach that and making that more of a force, so to speak. I'd be really interested in doing that. Because I think having base system libraries for Beehive management, jail management, interface management, PF, creating bindings for all the libraries, the C libraries that we have in the base system would be a really worthy project. But it needs some planning. So I'll show a few more examples in a bit. But right now the code is on GitHub if anyone wants to try it. Like I said, you need Lua 5.4 and CMake. And when you clone it, just type make and it'll build everything. It has to be done on a FreeBSD system at the moment. Hopefully that's not too much of a restriction. And yeah, I'd be really happy to hear any feedback or kind of any experiences people have. I will say that the documentation is really sparse right now, but I'm planning to work on it, during this conference. And so I think in a week or two, it'll be in a much better state. I've started writing a man page, and there's a fair bit of inline descriptions of various tasks in the code itself, but the UI is still being kind of worked on. So does anyone have any questions? I'm going to show some more stuff, but Warner's got something.
And I have some I can relay from. I'll relay two from IRC. Well, a comment from IRC first.
Okay.
Just Baptiste gave you hands for your name. Both Baptiste and Manor fully approve. I think Bapt also sent you hearts for Bricolage.
Yeah. So. Thanks, Baptiste.
I have a question I'll do, but I'll let Warner go first.
So Fluent and Base. Last year I had a summer of code student that used Lua to write the scripts to boot every possible boot combination that we have, but switched to Python at the end because we don't have basically a spawn or a way to do multiple threads. So.
Oh, well, multiple threads.
I want to spawn all 20 of these in parallel because they don't do anything.
Yeah.
And then wait for them to finish. So.
Oh, so sorry. I'll go back to this in a minute. So syscaller is running now. But so for instance, I have this POSIX spawn wrapper that I wrote in C. And I'm using WaitPid. So this is like a synchronous spawn and run. But yeah, if you wanted to do that in Lua, all you need is this thing, which I wrote. It's not in Flua, but I'd like to import it.
Yeah, I'd like that because I like his Flua version of the scripts better than the other stuff. So I think that also might be something to integrate with your stuff.
Because, just my personal feelings are Lua is actually a pretty nice language. It's very simple. The thing that it's really weak at is providing libraries, which is the thing one thing that Python is really, really good at. So I think, unless we're going to adopt Python in the base system, if we want something better than shell scripts and make files, which I at least do, we need to at least start with some C wrappers. And there's third-party projects on the internet that have done this. There's something called Lua POSIX, which provides a whole bunch of POSIX-compatible system call wrappers. They don't have POSIX spawn P, which is kind of annoying. And that's part of the reason I didn't use it. But it would also be very nice to be able to use capsicum from Lua, all these kinds of FreeBSD-specific features. But I think starting with these libc functions is a good way to start.
I wanted to rewrite config in Lua.
Yeah, exactly. But and I think you probably could do most of it today, right? It's just not as convenient as it could be because our libraries aren't really there.
Let me do a question from IRC first. Andy Turner asked about building an artifact on one system and then doing the execution on another. Is that kind of doable? Is it somewhat kind of have to manually know to copy the bits to the right place? Or?
Yeah, today it's not really doable. Not out of the box. You could certainly implement some wrapper on top of Bricolage to do that. I think if it was phrased a bit more precisely, I could probably see that as a feature request. Add an optional step to copy to SCP, build artifacts from place A to place B or to rsync them or whatever. I don't know exactly how that would look, but the whole point is Bricolage is a glorified command runner, right? It can do anything you want it to do. It's just a question of framing that in terms of a workflow. If you have some if that can be kind of fit into the hierarchy in a way that makes sense, then that's very easy to implement. But I guess I'd wonder do you want to do that after you build the VM image? Do you want to copy that over? Do you want to copy just the build artifacts?
So I think his use cases are I want to build on a fast machine and run on a slow machine. Maybe cross build on a fast x86 box and then go run it on my ARM box. Or I think you mentioned also being able to do one of the two steps on Linux, either running QEMU on Linux or maybe building on, I think it's more like running QEMU on Linux, but I think it's kind of separating the notion of building in versus when I actually go to run things.
Yeah. I mean, so like there's a natural separation in the framework itself, right? Like building a VM image and booting it are two separate things. They don't need to be connected to each other. So yeah, it's just kind of a question of how exactly you want to support that. So I personally have a very fast AMD machine at home that I use for everything. And then I use VMs to do most of the stuff that I want to do with this tool. So I haven't experienced the need for that yet, but I can see why. I can see why you'd want to.
Oh, okay.
Okay, so I guess, yeah, cross-system building is a pretty interesting topic for some people.
Do you have any plans for building this into a more of a CI model?
So my hope is that folks could take this and use it directly from their CI scripts, because the command line interface is such that everything is described in the command line. There's no support yet for adding a config file, which I think you'd really want for a CI system, but that's just I can do that very quickly. It's just I haven't yet because I haven't quite figured out how I want it to look. But instead of specifying all these parameters on the command line and getting them from a config file, that's easy to do. Yeah. So my hope is that yes, one could use this in a CI environment, and I tried to design it with those kinds of affordances in mind.
I think as a project, it would be very useful to have some sort of CI service, because a lot of us in this room have access to fast hardware that we can build and test things on, but there are a lot of people that are not in this room but want to contribute to FreeBSD. Some of them don't even have FreeBSD systems at all, but those that do, it may be a small system. They don't want to spend 5 hours building something on a laptop. So if there was some way that they could just send a patch somewhere and have it tested for them.
Yeah.
Obviously, we need to make sure they're not testing Bitcoin mining, but I do think it would be very useful to have some sort of service for people to access.
Yeah.
Don't submit a pull request for it. You can do Cirrus CI on GitHub.
If you don't submit a pull request for it.
Push it to a branch.
Oh yes, I see what you're saying. Yeah.
Turn Cirrus CI on your repo, your port.
Yeah.
Then it will run, and it won't be part of FreeBSD.
Yeah. So in your Cirrus scripts, yeah, you could download this tool because so Cirrus is a CI service or hosted CI that lets you target FreeBSD as a native platform, which I think is the main appeal of it for us. And you also get some amount of free credits per month, I think. So one thing you could very easily do is just clone this repository as the first step of your build process and use it instead of hard coding your make build world, make build kernel, whatever else you want to do. So I think, yeah, that would probably be the ideal way to use it in CI. So to Colin's point, yeah, it would be nice if there was some kind of, I don't know what you want to call it, an orchestration layer on top that takes idle CPU resources and uses this tool to do builds and so on. But I would say that's a bit out of scope for what this thing is trying to do, because that sort of resource allocation is a bit that's something we have the universe machines in the FreeBSD cluster. And you can run this there. I've been doing it, and use it to generate emails periodically, for instance. But how do you make sure it's not over-provisioned? If 4 people are doing the same workload and you're running VMs, if you're running compilers and VMs on the same system and the CPUs are oversubscribed, you're going to have a bad time. So there's a need for, I think, an additional layer to do orchestration on top of this.
I'm thinking particularly of contributors that are not committers. Contributors who aren't committers won't have access to the universe.
Right. So yeah, Colin points out that contributors who aren't committers won't have access to universe. But that may be a good place to stage builds for patches from contributors. But that would require some kind of exclusive access to the systems. So I don't know if there's some support planned for this. How much time do we have left? 20 minutes. OK. I've noticed the universe machines are also very slow. Like there's Sandy Bridge, which is, yeah. So I don't know if as part of the cluster refresh that I think Joe mentioned, there might be access to newer hardware for doing builds. But this might be a really good use for that. Because as far as I know, the universe systems are mostly idle. People don't really use them. But yeah, again, if you use this today, you can run the test suite without having to do much, so long as there aren't other people running builds at the same time as you. So I guess the short answer to your question is yes, but I think there's some stuff that needs to happen at a higher layer to provision resources to run this tool.
So does anybody have a way we can run FreeBSD native jobs on GitHub?
Yes. So if you do a self-hosted GitHub runner, I think David Chisnell wrote some scripts whereby you can there's a project which kind of implements the GitHub runner API that's defined by GitHub. I guess they reverse engineered it. And so you can use that to run GitHub actions in your local environment. And I've done it, and it kind of works. But I think there's a lot of security implications if you're turning that on a repo where other people can,
Yeah, well, we have, yeah.
CIRC. Yeah. I haven't tried it in maybe, it was maybe last year that I tried it. So you can do it. You basically define a FreeBSD jail and run the agent there, and it'll do builds and stuff for you. And it mostly works.
I'd like to get that turned up for our GitHub pull request stuff, and this looks like it would drop into that nicely.
Yeah.
Our
But
GitHub pull request stuff, the problem is that we're not providing resource.
Yeah.
One way or another, we have to provide resource to actually run the documents. And it can't be Syric. So we can pay Syric, pay for Google Cloud or whatever the heck we want. Or we can buy our own and run it on Syric CI and it'll just work. The problem right now is that money's not free anymore, so they had to stop providing CI credits. But you can still use it on your own as long as you don't have a pull request.
Well, I think also, so Baptiste mentioned, I think the thing you were talking about, Mark, the reimplementation of GitHub's actions. I think what we're kind of describing is, for example, you could host that on our universe machines, and then maybe we do something like a specific label that a committer has to tag on a PR before we'll actually run it to try to constrain and have something that scrapes our pull request to see if something is labeled in a certain way, and so then kind of schedules it to run on the universe machines that way and feeds back, maybe something along those lines, perhaps.
right now I have to approve new committers running on GitHub.
But I think a lot of this, though, is a lot of the orchestration is a layer on top of Bricolage as opposed to an intrinsic feature of Bricolage itself, right? I think when I've spoken with Mark, one of the design goals that I would appreciate about this is the ability for myself at least to run CI locally before I push something as a developer, which is, that's that's one part of the puzzle as opposed to the providing a good way to validate external contributions and giving us confidence about being able to kind of more do automated validation or improved validation of external contributions so you feel better about pushing things that we haven't written.
Are there any more questions?
Yep.
Yes, Mark, I was wondering, for some of the tasks where you spawn VMs, actually, can we choose, for example, to launch a QEMU or Beehive? Can we switch backends? And would you consider as well some patches to have a VirtualBox as a backend?
Can we switch backends? Yes, yeah, you can do it today. So sorry, because I can't, it's not a mirrored display, so I have to turn my head to type anything, but I'm just trying to find an example here. Okay, so.
Well, you were running Beehive before when it gave that nice error message about not having a ZFS pool set up.
Yeah, so, okay, so here's an Ampere system, courtesy of Clara, which I've been using to test Beehive-related stuff. So I'm logged into it right now over FreeBSD Wi-Fi. And yeah, so again, like, I don't love this syntax, so again, any hints on the UI would be really appreciated, but you can see there's FreeBSD source regression suite run hypervisor equals beehive. So by default, it'll use QEMU, but yeah, if you wanted to add a virtual box backend, that would be fine too, as long as you can do it through the command line. There's, again, because it's Lua, it's a bit primitive. Like, like Lua doesn't have classes, so I had to write classes. Like, I have to make my own kind of abstraction for that. So there's, you know, a base VM run task or class, and then there's some specific methods for beehive and QEMU. So yeah, you could easily add something for VirtualBox as well. So in this particular example, you know, there's a few other parameters. I ask it for 32 gigabytes of memory, 16 CPUs, and instead of running the whole regression test suite, I just want to run the bin.sh tests. So if I do that, you know, you can see it kind of running. It'll update the source tree because it's pointing at the canonical FreeBSD sources. So every time somebody commits and you run this, you'll get the updates. And now it does an incremental rebuild. There's a lot of weird noise in our incremental builds, like that find. I don't know what that's about. Lots of annoying dependency errors. Anyway, so this takes maybe 30 seconds, even though the hardware is pretty fast. So one of the other things I'd like to improve is just the ability to avoid even going through this incremental rebuild when possible, because it's pretty slow. But you can see it's already on the kernel. Now it's installing everything. Some more find errors. Yeah. Go, go, go. And so while that's running, I'll go to a previous tab where I wanted to show an example, but they shut off the power at home. So I was running the RISC-V regression test suite, and it actually panicked. And so when the regression test suite panics, you know, it stops in the debugger. But what I was able to do was basically from another terminal just attach a debugger. So the syntax was basically just Bricolage run, you know, FreeBSD source regression test suite GDB, and then it would attach a debugger to this VM, and you can get a backtrace and start debugging. So again, my session is lost, unfortunately, but that's the kind of thing I really want it to be easy to do. So if you run the FreeBSD regression test suite and you hit a bug, you know, you can give your invocation to somebody else, and hopefully they can reproduce it without a lot of work on their part. You don't have to, you know, give them any scripts. You don't have to make a whole bunch of assumptions about their environment. All of that kind of messy logic is handled in the framework. OK, so it booted up the VM. It's installing a whole bunch of packages, nested tmux. There we go. So this is ARM64 beehive. You can see it has all the 16 CPUs. It has 32 gigs of memory. And it's going and running the tests. And it's very fast because it runs them in parallel by default. And then it generates a report and copies it back to the host system. So having done that, I can now run this command at the bottom, wherein, you know, I name the same task again, and then I add kind of a subcommand report, which you could, you know, for instance, paste into an email. And then that's just the queue of results of the test. It's not very interesting because all the tests passed, but all of the details you'd kind of want are there. It's actually a lot of output, but yeah. So yeah, ran 506 tests, no failures, great. BinSH has no bugs.
That's a bold claim.
But like, hopefully the utility is kind of a bit more clear, right? Like, to do this kind of thing using tools in the base system, like I have to write a whole bunch of scripts. But having a bit of a framework that's not too intrusive, that lets you kind of that lets each task run its own working directory, that lets you define parameter namespaces and so on, I think makes things a lot easier. So yeah, I don't think I have too much else to show. I have syscaller running over here. I can try to show that. I don't know why it keeps trying to open Slack. I don't want it to do that. So this is just syscaller running on my laptop. But again, I didn't have to do anything. Like I just typed in the command and gave it a couple of parameters, and it just figured it all out. So yeah, that's kind of the spirit of the tool, right? Like it lets you sort of incrementally discover what's possible because it gives you ways to list all of the tasks, list all the parameters to the task. It tries to not give you too much information, which I think is a problem with cherry build. If you want to list, like, the usage message for cherry build is like thousands of lines long. So in this case, we have more of a sort of hierarchical namespace of parameters where you can separate parameters that relate to checking out a source tree from parameters that relate to booting up a VM, because those are different things. So I think that's all I really wanted to show. Yeah. Oh, and I have stress2 running. So again, stress2 is just another FreeBSD test suite. There's nothing really magical about it, but we have no tools to actually run it. If you want to run stress2 today, you need to know, where to copy the test suite from, how to build it. All sorts of details are not really interesting. But with Bricolage, you can just kind of specify a few parameters and have it go. And here I can demonstrate the GDB thing. So I have it running in one terminal, and then there's this FreeBSD source stress2 run. Sorry about that. I'm almost done anyway. So now I have a GDB attached to the VM. The VM has stopped. You can see one of the CPUs was acquiring a reference to a jail. Okay, I mean, that's not intrinsically useful, but being able to attach a debugger like this after a crash is pretty nice. And so because the VM runs under orc, which again is this kind of expect-like framework, you can do expect-like things, so you can match on particular patterns in the console messages. So one patch I have, which I haven't committed yet, but seems to work, is if the kernel panics, it'll automatically detect that, and it can run a bunch of debugging commands, get more output, and save that. Again, all automatically, which is something we don't really, we don't have kind of canned tools for today. So hopefully, if like me, you do a lot of kernel development, hopefully you can see the utility there. But yeah, I think that's all I had to show. Are there any more questions?
Okay, I think we're good. Thank you very much, Mark.
Yep.
Lunch is going to be out in the hallway with the folks who are attending the tutorials. So you can grab a plate, go through the line out there. I think we have the break is an hour, so we're back here at 1, I believe. If I'm wrong, I'll tell you later. So I think we're back here in about an hour for starting up again. So thank you all. See you all in a bit. Yes. start up again for the afternoon. So folks want to make their way to our seats. So we're going to start off this afternoon with a more interactive session, a working group shared by Doug, talking about OCI containers on FreeBSD, well, containers running FreeBSD.
Is this mic working? Yes, I think it is. Okay. Okay, so we've got quite a long time slot. I'd like to make this kind of an interactive thing, so I'm going to try and keep an eye on the audience, interrupt me anytime to ask questions, get clarifications, or just tell me where I'm wrong. That's all good. So OCI containers. OCI stands for Open Container Initiative. It was created to create standards around the work that Docker did in the very early days of Linux containers. Its mission is to create standards for how the different components can interact. And it ended up proliferating the different ways of attacking containers into a lot of interesting areas, broadening the original Docker monopoly into a complete ecosystem. So I'm going to talk a little bit about the current status of FreeBSD support for OCI containers. And I'm going to talk about some of the details of container images and possible steps towards having officially supported FreeBSD container images. I mean, that's something which several people have pointed out to me is kind of blocking them from being able to use FreeBSD in certain contexts. For instance, with Podman, the Podman port, it builds in their CI, but we can't test it in CI because it needs a base image that they can't trust by their rules. Until we have a FreeBSD owned and supported trustable image, we can't build that test image that would then unblock FreeBSD being fully supported in their CI. So a couple of other similar conversations have happened over the last year and a half. So let's get started. FreeBSD OCI is based on jail and VNet. I mean, people have been running containers on FreeBSD since before Docker existed. We just didn't call them that. I think jail's been around since 2000. VNet, which pretty much adds the missing components to let you do interesting networking effects with jail. That's been around since, I think, 2007 or so. Not sure whether it was production ready in 2007, to be honest. So anyway, FreeBSD could do containers for a long time. When we add that with other things like nullfs and the PF packet filter, we can do really interesting things, and it covers pretty much the whole feature set of OCI containers. So a few years back, Containerd was ported to FreeBSD by a guy called Samuel Karp, who I wish he was here, but he's super busy. He's a really nice guy, and he comes from the OCI community and wanted to apply what he already knew about OCI to try and get things running on FreeBSD as a personal project. So he wrote an OCI runtime called runj for FreeBSD, which is, the runtime is like encapsulates the details of creating the container. So Containerd could then use this runtime to create jail-based FreeBSD containers. It actually works. I could run it now, but maybe I'll do demos later on. It's missing support for networking, which kind of makes it difficult to use for most real workloads. But it does work. And I think with a little more attention, it could be turned into a complete implementation streamed. So the Podman source code just builds out of the box on FreeBSD and works. The FreeBSD build is in their CI, and they actually care about it being supported and not breaking going forward. They've been a very supportive group. I'm talking mostly about the Red Hat engineers that do most of the work on Podman. They've been very supportive of this work, and that's been quite nice, actually. Going beyond that, a lot of, I don't know what the proportion would be, a lot of Linux containers run in Kubernetes, which is a clustered container orchestration system. again, that relies on a smaller component that manages the lifecycle of containers for the cluster. So there's a couple of different approaches to that. Containerd is one. One is a thing called CRI-O. CRI is Container Runtime Interface, I guess. CRI-O is an implementation of that. And I ported that to FreeBSD. And using that and some hacks on top of Kubernetes, I was able to run a FreeBSD native Kubernetes cluster on 2 virtual machines in my home lab. It's not a scale-up thing. But so I've been working on upstreaming that work. Parts of it are in review. The one outstanding review, which when that lands, will have functional support for FreeBSD Kubernetes nodes. And there's some follow-ups to add more functionality. So that's a work in progress. I've got hacks on the kubelet component of Kubernetes, which is kubelet runs on all machines in the cluster, and it's responsible for starting and stopping containers as things get migrated around the cluster. So I have a port of kubelet. I have a port of something called kubeproxy, which manages the Kubernetes networking model, which I don't really want to go into here, but it allows for virtual IPs to map to services within the cluster. So I have those 2 ports. I'd like to upstream them, but I need to work out how the Kubernetes development model works and get the right people in that community to buy into actually having this as a project. Okay. So for networking with containers, we rely on something called CNI, Container Networking Interface. There's a lot of TLAs in this system. They're basically a set of plugins, like separate binaries that run to do specific functions. And those functions include looking around to see if you have the right bridge already. If not, create it. Create an e-pair, add part of it to the bridge, poke part of it into the container, allocate IP addresses, set up the IP addresses within the container, that kind of thing. So I ported an absolute bare minimum of CNI plugins for FreeBSD, and that's enough to support typical desktop Podman type usages. In cluster environments, there are more complex CNI plugins. I've looked at Flannel, which is very popular, and I think that could be ported fairly easily using FreeBSD's VXLAN. There's another popular plugin called Calico, which uses BGP to manage some of the routing for Kubernetes networking. I think that could be ported, although I'm worried that they seem to be moving to eBPF for their implementation, which might be a challenge. For my own purposes, I just set up a simple VLAN-based network. These more complex systems that require VXLAN and so on, they're in much larger clusters than I'm able to test. Any questions so far? So what's a runtime? I talked a little bit earlier on. A runtime is a separate program that the container engine, like Podman, CRI-O, Containerd, or whatever, shells out to the runtime to perform tasks on the container itself. So it allows, it's an isolation. It's an abstraction layer on top of the life cycle of the container itself. So for us, that life cycle involves creating jails, mounting file systems into the jail's root file system, perhaps offering a point where we can hook in initialization for the network. So creating the jail involves maybe creating a VNet for that jail and so on. We've got 2 implementations of the runtime. RunJ was the first one. That was Sam's work that was intended to support Containerd. I started using that, and it works quite well. I had at one point, I had a lot of patches to it, and I had a conversation with Sam. He was like, I want to do most of this myself because this is a learning process for me. And so I was like, well, I don't want to fork your work. So I think I'm going to write my own runtime and so that I can control the pace of development. And then we can try and converge again in the future. So I wrote this thing called OCI jail, wrote it in C++ because I understand C++ better than Go. And I'm mostly aiming for compatibility with Podman. Long term, there's no real need for two of them, but right now that's what we got. I can imagine writing an OCI runtime based on Beehive. There's not much of a barrier to making that work. I think the 9PFS work that I've been promising to get into the tree for a long time is an enabler for that because it allows the host to prepare a root file system for the container and then have Beehive run it. Don't quite understand how networking would work, but it would involve probably a CNI plugin that creates a tap and then some sort of agent running inside Beehive to apply the IP addresses to the interfaces and so on. I need to look and see how the Linux people do this with VMs, but it's certainly possible. So, next steps on this part. I mean, ongoing work to keep the Podman ports up to date. Podman, like I said, usually builds out of the box. Because we don't have full exposure in their CI, it doesn't necessarily work out of the box. So a regular chore for me is to update the ports, test them, hopefully not find any bugs. If I do, fix them, upstream them, and then basically freshen the ports from there. Kind of cycle I've been going through is find minor bugs, put them as patches in our ports tree, and upstream them after the fact, and that's been working reasonably well. So there's ongoing work to keep that fresh. We've created a working group within the OCI infrastructure to define what a FreeBSD runtime should do. This is going to allow us to align the two runtimes, RunJ and OCI jail, to make sure that they're not pulling in different directions. It's going to make it clearer about exactly what features we're supporting under OCI for OCI containers. We've just started this work. We've had a few meetings. What I would like to get from people is what they would do with a working FreeBSD container infrastructure. What problems would they try and solve with it? And we can try and make sure that we map that onto the specification that we're developing. So user stories are really important, basically use cases. As a user, I would like to be able to do X with a container on FreeBSD. Containerd support is lagging a bit, mostly because it's been worked on by people with not enough spare time. It would be lovely to see better support in Containerd, perhaps with some support for networking, with some support for basically running CNI plugins at the right moment so that they can have parity with the Podman implementation. I think monocultures are a bad thing. So having two container engines with good functionality, I think, is going to be good for us. I need to finish upstreaming the CRI work that I've done. I need to work out how to get the rest of the components for FreeBSD on Kubernetes reviewed and upstreamed. The kubeadmin programming Kubernetes is basically a way of building small clusters. There's an X509 crypto infrastructure underneath the cluster that's quite difficult to set up. You don't want to do this manually. Trust me, I've done it. I didn't want to. kubeadmin basically does all of that for you. So I need to port that to FreeBSD. It's not going to be complicated. It just changes a few path names here and there to put things in underneath user, local, etc., instead of slash, etc., and things like this. So I need to get that done to make it easier for people to actually try out FreeBSD on Kubernetes. Anyway, so let's talk about images. Containers with OCI rely on images. Pretty much all OCI containers are built on top of images. There's some rare cases where you might do something based without an image, but almost always it's with an image. An image is just a read-only directory tree that contains contains runtime dependencies, such as shared libraries, config files, SSL certificates, along with the application that you're going to run in the container. So container takes an image as a starting point and adds a scratch layer on top to isolate anything that it changes inside that image. So the container runs, maybe things happen and it modifies the root file system. It doesn't touch the underlying image, it's held separately. This means you can be clear about where the state of your container is and how that can be separate from the underlying image. And it's good practice, in fact, to find that state and try to explicitly put it into a mounted volume so that you can literally trash the container and start again and still have your state. So the OCI image format is content addressed layered format. When I say content addressed, it's each component is hashed, and the name of the hash and the result of the hash is the name of that object. So if you use hashes, it's to name the various objects. When you download things from an image registry and you happen to have some of those components, maybe there was a shared base image, it's really easy for the local storage to say, hey, don't fetch that hash. I've got it in my storage already, so it can dedupe. So different objects is like a graph of objects that are doing different parts of the work. The most important part is the image manifest. The image manifest defines the contents of a single image, and it basically lists a number of tarballs that should be unpacked one by one on top of the other, to make the final content of that image. And this allows you to extend that by adding new layers that perhaps install applications or delete a config file or change something. So the manifest defines the layers that make up the image. Then you can combine those manifests into image lists. Supposing I want an image that's going to run on all the FreeBSD Tier 1 platforms, and maybe all of the FreeBSD Tier 1 platforms maybe supporting different OS versions of FreeBSD as well. I could build an image list that lists the manifests of the hashes of the manifests of the different implementations, like an x86 version of the image, an ARM64 version of the image, a RISC-V version of the image, and it lists those different hashes and lets the container engine pick the right one when you try and run the image. So image lists allow you to make what appear to the user to be multi-platform images. So as I said, all the references between different things in this graph are using the SHA-256 hash of the object being referenced, and the leaves are files that are typically gzip compressed tar files that contain a delta from some other image, or perhaps if it's the first one, a delta against the empty image, so for the base. So SHA-256 hashes are not a terribly user-friendly way of naming things. So apart from so image registries will store all of these content addressed objects underneath using the hashes, but they also build a human understandable namespace on top of that. So an OCI image name might look something like docker.io/doug-rabson/hello:_latest. So let's unpack that a little bit. Docker.io names the image registry that you're trying to use. It's a resolvable domain name. And we expect to find a registry. It's an HTTP server running a REST protocol that has functions to do various different things to manage the registry. So the next part in this tuple effectively is the namespace. So in this example, it's Doug Rabson. That's where I put some of my stuff on Docker Hub. And you can use this to group related images together, or in my case, to carve out my own small part of a shared infrastructure. The last part names the image itself. And again, there can be multiple images grouped together. So here we've got hello:_latest. We could have hello:_version 1.0, 1.1, whatever. And the latest is typically used to name the most recent version of that image. But in a normal setting, perhaps with FreeBSD images, we could have use tags to say, okay, this is the 14.0 patch level 1, patch level 2, and so on, so that we can keep a library of images at the different patch levels. So when people perhaps validate their application on one specific image, we don't want to force them to upgrade to some other patch level. Maybe we do, but we don't have to. So they can, if we keep them around in the registry, they can always fetch the exact image that they tested and validated for their product. So let's look at some examples. Hope you can read this. So this is a typical image list. So we can see that it's typed itself, and you will see the type on both ends. The object stores its own type, and references to the object have to match that type. So this is saying, I'm expecting to find an image manifest v1 in JSON format at this hash. And whoever was referencing this image list would have expected to find an image index v1 in JSON format at whatever the hash of this is. And this is literally, the hash is literally the SHA-256 of this piece of text. So this image list has two images in it. They're both FreeBSD images. We've got two different formats, two different architectures supported. There's AMD64 and ARM64. So if I run this image on my Raspberry Pi, it'll pick this one. If I run this image on my desktop back at home, it's going to run this image because it's an x86 system. So this platform is a tuple that describes the image, the platform that can run the image. And we can, it's actually, this is only showing part of it. For the architecture, you can have a variant field. So we can say ARM64 with AArch64, or perhaps some other ABI. ARM64 with ARMv7 as a variant. You can actually, on Windows, they use a version field here. to specify the ABI version. And this is something which was potentially interesting for FreeBSD as well. So we could use that to say, this is an image that was built for 14, or maybe 14.0, and it's got the other features. And then we can build multi-platform images that have back compatibility because they will work on, say, FreeBSD 13 or so on. But you don't have to think about that when you use them. I haven't tried to use this. I know this support is completely missing in Podman. I think it's only implemented in Containerd. So using the version option would take some work, but I think it's quite potentially useful for us going down the line because of the way FreeBSD defines ABI compatibility for user land. So this is an example of an image manifest. Again, I hope you can read it. It's saying, I'm an image manifest in JSON format. So the pointer that was applying to it can validate that it's not pointing something stupid by checking that. It's referring to another object called the image config. I'm not going to go into details on that, but that contains things like what environment variables to set for the image, what's the default command that's going to run unless you override it, metadata about how it was built, maybe even a description of the image and so on. It's quite freeform. Alongside the config, we've got the layers that make up the image, and these are applied in order. So this guy, I built the image, so I know what's in it. This guy is just the result of running mtree on an empty directory to create the FreeBSD directory tree. This one, I think, adds SSL certificates and stuff into the image. This one adds some libraries like clib, and this one adds the FreeBSD runtime package base package, which adds a shell and some utilities. And the result is an image where you can run a simple shell without much support there. You can have metadata in this as well. So this is saying this was built from 14.0 patch level 6 package base set. I actually built this from the FreeBSD published packages. It's been nice to have package base supported out there on the FreeBSD infrastructure. So this part is saying this is the name that it had when I built, because this is intended to be used as a multi-platform with a multi-platform image list. But when I built it, I build them one at a time with more specific names, and that name doesn't usually get pushed. Okay. Questions? No. So typically, people don't build their own base images. In Linux images are typically applications installed onto some base image, and the base image will contain the libc, it's going to contain all the other libraries, it's going to contain certificates, sometimes shells and tools and so on, and your application is just layered onto that. I think one of the motivating factors for containers on Linux was they had so many distributions. And people wanted to be able to run a Debian application on their Fedora box and vice versa. So this way of packaging up the distribution artifacts alongside the application allows that portability. It's not so much of a problem for FreeBSD, but it's still nice to be able to run FreeBSD 13 stuff on a FreeBSD 15 dev. So, we have a much smaller problem, but it's still something useful to do. There's been a lot of evolution in base images on the Linux side. people have been innovating, trying to optimize for space. The smallest image I was able to find is Alpine, which is 8 megabytes for something that supports a shell plus utilities. It's pretty interesting. That one is built on top of BusyBox, which has been around for a long time, been used in embedded work for the same purpose.
It's basically /rescue.
Yeah, yeah. Rescue is a bit bigger. Yeah.
Not a lot. It's that same order.
Yeah.
It's not the 78. It's like 12.
Yeah. So just for the recording, Warner said it's like /rescue, and yeah, it absolutely is. And I think that BusyBox was probably inspired by Rescue. I built a FreeBSD BusyBox because BusyBox is in our ports tree. It's not as complete as the Linux BusyBox, but it's got some interesting stuff in it. And when I was trying to build base images for Podman CI, I wanted an image that behaved as much as possible like the test image that they were using, that was built on Alpine. So I just built it based on FreeBSD BusyBox, and that was about 8 megabytes. So more traditional kind of, for the people that don't know, Rescue, BusyBox, they basically take a lot of utilities and squeeze them all together into a single binary, so they can share a maximum possible amount of code. And they usually it usually makes them much smaller than having many separate binaries. Without doing that, the smallest image I could find was 78 megabytes for Ubuntu's base image. And this is has enough functionality to run a shell and install some more packages, basically. Often, there's no need to have a shell. If I'm just running Nginx as a proxy, I don't think I need much more than libc, actually. Maybe I need some SSL utilities. So Google started up a project called DistroList, which provides super small base images that contain as little as possible. Their motivation was making them small and reducing attack surface for when there are compromises. If there's no shell, then the attack can't shell out and do something within the container. I don't know how important that is from a security point of view. Multiple people have told me recently that Linux containers aren't intended to be a security fix, that you need to look at VMs to do that. But they certainly reduce the attack surface if there is a compromise. Some workloads don't even need shared libraries. I have one that's based on something called Catatonic, which is the smallest and dumbest version of init that they could implement. It's a statically linked application that has no config files and has no dependencies on any other parts of the operating system. You can just build an image containing only that binary, nothing else. Works well. I think that's a special case. You often need a bit of configuration stuff. A lot of things need SSL certificates. A lot of things behave better if they have time zone files. So the DistroList project creates a static image that contains just config files, no shared libraries. It contains an image called base, which contains shared libraries. And then there's a range of other things that contain things like toolchains, Java, C, C++, and so on. But I like the idea of having small images. And I like the idea of having images that didn't give you a shell even if you didn't need it, or give you man pages that no one's ever going to read. Let's think about FreeBSD images. I mean, I think that images are important to give image developers somewhere to start. It's give them something they can trust. And this is something which people have told me, that they want to be able to have a base image that they can prove has been developed by and supported by the FreeBSD project, and not some random person called Doug Rabson that says, download my image from Docker. Go on, it's going to be fine. mean, maybe you guys know me, and maybe you trust me. Maybe you shouldn't. I don't know. But somebody else that's not been part of the FreeBSD project has no idea who I am. And why should they run my image? I remember somebody was porting a component of containerd, and they were wiring up to the CI, and they wanted to use one of my base images. And the comment came up in the review is, what is this image? And why are you using it? So yeah, I think it's important to have images that the project supports. And the then question is, what goes in the image? I mean, base.txz is huge. Last time I looked, it was about 1 gigabyte once you unpack it. It's got everything in the kitchen sink. It's great if you're building a physical machine. You need all of that stuff, and that's FreeBSD's selling point, like a complete system. But for container images, you don't need the complete system. A lot of times, you don't want the complete system. You certainly don't need all the shell utilities and all the man pages when you're just running your Nginx proxy. Fortunately, package base kind of helps us a lot here. Package base breaks up that monolith of base.txz into about 400 odd much smaller packages. So we could use that. And in my experiments, I certainly used that. That image which I showed you earlier was built using package base to layer in different package base packages on top of other images. Package base has more than 400 images, so we can't offer all the combinations. What's 400 factorial? It's too big. There's too many combinations. We have to narrow it down a little bit. So I'm going to follow the path that's given by Distrolist and say we should have an image that supports static-based workloads, like statically linked programs. We should have an image that supports dynamically linked programs that don't do any shell stuff. And when I say supports a strong enough subset for that to be viable. Within those dynamic workloads, it's very common to require SSL. It's very common to need time zone stuff and probably some other config files. So salt in whatever extras that improves the compatibility of that image. And even if we miss stuff out, it's OK. It's really easy to add the missing shared library or whatever when you're building your application. Things are a bit more varied for shell-based stuff because the nature of shell scripts is that they shell out and do stuff with all other stuff in the image, like the different utilities. But the smallest image that we can build with package base without breaking open a package and installing fractions of it is an image that's based on the FreeBSD runtime package base package. I wish it wasn't called package base, actually. It seems weird to say package base package still.
We need another French word.
Maybe we do. What's French for package? That's a good one. The comment for the recording, the comment was, we need another French word. So anyway, we can build the smallest shell-based image that I can build with package base is based on FreeBSD runtime. And it turns out that comes in at about 70 megabytes, which is similar to Ubuntu. So we are competing. This is great. That actually doesn't have much in the way of command line utilities. So I often add the FreeBSD utilities package, which has a much more complete set that allows for more shell script compatibility. What should we name them? I don't like the names from Distrolist. Base is confusing for us. We see base and think a gigabyte in a big compressed bundle. What should we name stuff? If we can get some consensus on what to put in the images, we should probably try and figure out names that work for us. I suppose we could use the name of the package-based component. that ends up with something which I don't really like the look of, like CA root for the static bit, clibs for the dynamic bit. I don't think these are great names. I don't know. I'm not good at naming things. I mean, I called my project New Bus because it was a new version of Bus. Yeah. So I'm open to suggestions on what goes in these things and what they should be called. But I think we need them. I think if we can narrow it down to just 3 images, like literally for those 3 classes, static, dynamic, or doing a bit of shell, then that's going to be enough to get people started. And the image that I build for the shell also has package pre-bootstrapped so that you can very, very easily write a Docker file that says, hey, start from this image and install utilities or install Cobros or whatever it happens to be that you need that wasn't in that image. So I think it gives us enough for people to build on and do whatever else they need. And with package-based being available in our own kind of CDN, then that's enough to get people started in most cases. So how do we go about building these things? Assuming that we have consensus on the contents and the names, we should be able to build them. It needs to be part of the FreeBSD release process. If the FreeBSD project is going to support these images, it has to have built them. And we have to be able to show that the artifacts we're offering are actually the ones that were built. This is really important for the release engineering team. We've had conversations about this. So it should be part of the FreeBSD release process. It should be part of the regular snapshot building process. I've looked into hacking on the source/release part of the source tree, perhaps changing release.sh to add an option to build OCI images. And we could export these images as OCI archives, which basically takes all of the objects, the layers, the manifests, the image lists, and adds them to a standardized format tarball. So those artifacts could then be published alongside base.txz, perhaps, or somewhere else. Colin?
We'll talk after I get 14.1 out the door. I've got a couple of emails about this that I need to deal with, and this 14.1
Right.
was getting in the way.
Yes. Question is, was the question about should we have these as part of 14.1?
No.
No.
They're not 14. I'm building 14.1 release on Friday.
Yes.
But that is why nothing has happened about this yet. I have not been able to get back to the emails, but
Right.
I will soon, I promise.
So yeah, Colin's saying, yeah, 14.1 is stopping release eng from thinking about this stuff, and that's absolutely fine. And you know, I know some of the people that probably were writing those emails, and I told them they've missed the boat for 14.1. That perhaps we could do something after the fact, but the release is going to be cut this week. Yes. So maybe people have had exciting expectations, but it's not going to happen for 14.1, and that's okay. I want it to happen eventually. The time span is not important, as long as it happens, because the time when it's not happening, it stops people from using this project, and I want people to use the project. So yeah, we could implement build individual platform images, like not the image list thing. We could create archives, which are tarballs, so they're build artifacts that we can store in the result of the build. Perhaps put them alongside base.txz so they can have verifiable checksums that we create as part of the build process automatically. We can put them somewhere on download.freebsd.org. It's easy to download these things and add them to your own local registry. Scopio is a utility that the Red Hat folk wrote to manage images. It predates Podman. They were using Docker and they just wanted some better tools. So they wrote this thing for moving images between registries. And one of the things it can do is import and export from tar files. It's quite nice. Podman image load is a subcommand of Podman that does basically the same thing. So you can, supposing we had a future where there was a well-known place on download.freebsd.org that contained OCI format image archives. People could import them into their registry, run a local registry, import them into that, and use them. So thinking about the release process, it's kind of opaque to me, but I don't understand how patch releases work. Package-base is able to hook into the patch release building infrastructure so that it can publish new package-based sets when there's a new patch level. I don't know where that goes. Release.sh does one particular, I can build from an arbitrary Git hash with release.sh. But what I really want is somewhere to hook into the existing infrastructure for building regular releases, like snapshots and patch releases. That's something which I'm going to have to ask people how it currently works, because it's all a bit of a mystery. Distribution. I talked about people perhaps downloading stuff from download.freebsd.org. That's not really how people do that in the real world. Registries are there to make it easy to use images. And one of the things that makes them easy is you can just take a name of an image, including the name of the registry, the namespace, the repository, the version, and just say, pull that and run it. And this just, it looks in your own local storage. It downloads the bits that it doesn't already have, and then it runs it. And that's done by the registry. So the registry has two jobs. I said, I'm adding a third job. I said two jobs earlier. The first job is to store the stuff. Second job is to name the stuff. And the third job is to give network access to it, pushing and pulling for people using the image or updating the image. We could run our own. There's the Docker registry works really well. It's in the ports tree. We could use that. There's a newer implementation of registry, which I use locally in my lab, called Zot. I think we'll probably get that into the ports tree at some point. It does the same thing, but it has a little web UI on top, which makes it pretty. Also, it does some image signing verification stuff and has hooks for vulnerability checks as well. We could use existing infrastructures. One of the nice things about the OCI formats and the standardization process is that without any changes at all to the existing infrastructure, I can use Docker Hub to store my FreeBSD images. I can use Cray or GHCR because they all implement the same standards. So we can use existing infrastructure that the Linux community already uses to download millions of images every day, probably. We don't even have to build out our own infrastructure for this. This is great. So we could use existing infrastructure. GHCR is interesting because we already use GitHub. GHCR, for people that don't know, is the GitHub container registry. Okay? And the way that works is it goes with the GitHub users or projects. So GitHub/FreeBSD is something which we already own and manage. And so we could potentially use that to store images and to give access to those images. And that would be a place that's provably controlled by the project. Still kind of like registry.freebsd.org, though. We should distribute multi-architecture image lists, as I mentioned, so that people don't have to remember what type of computer they're using. They can just run stuff. It's not helpful to use a different image name on the different platforms. And it actually makes it more difficult to build building multi-architecture images is built into the Docker file kind of process. A Docker file describes a set of steps to modify some image and create a new image. If the starting point was multi-architecture, and I provide the right command line flags and build it with, say, Podman or Builder, it can build all of them and package the rest into a new multi-architecture image list. It's super easy. That's what I do for building these images. I start from a multi-platform base image and then layer in multi-platform variants on it. So we should absolutely support that. So we're going to have to tie together the artifacts that we built earlier on and make sure that we can link together the matching images from the different architectures that we support.
But you do have to download the entire thing then?
No. So the comment is, the question is, do you have to download the whole thing to be able to use the multi-platform? This is the beauty of it. You have to download the image list. And then the image list will tell you which other thing to download. You don't have to download the other parts. The image list itself is tiny. So you look through the image list, find the best match. That gives you the hash of the image manifest. Again, the manifest is tiny. You download that. That tells you the hashes of the layers you need. And you may have some of them already. So you look through your local storage and download the pieces that you don't have. So it automatically gives you a minimal download. I don't know whether it caches the image list locally. I think it probably does. So.
Which part exactly made the decision that, okay, I fetch this image, the first layer,
right.
Then
so let's.
this is AMD64, so I want to go this direction.
Let's go back to the example. Okay, this is that image list. So if I have some name that refers to this image list, like FreeBSD stuff, I tell Podman to run that name. He looks at it, says, OK, that's an image list. I can tell because it's of the type. So then he looks at the local platform, says, OK, we're running FreeBSD. That's great. It's ARM64. Let's say I'm doing this on a Pi or something. So the image list then tells him that this is the hash I need. This is the hash of the image manifest that's going to be right for this platform. Then we can then look in local storage to see if we have it. If we don't, we download this hash from the same registry that we were talking at.
Because Podman looks at the architecture bit from the platform?
Yes.
Or he ignores architecture that he doesn't? Because
so he looks at the architecture is pretty much, no, it's not fixed. We can run emulated images. So we'll start by, Podman starts by defining the platform tuple. It defaults to the operating system which built it, like FreeBSD. It defaults to the architecture that's currently running. So let's say that's so it's ARM64. Then there's command line flags to let you override those things. So I can say, I can be running AMD64, but I actually want to run the ARM64 image under emulation. So I can override those pieces. And I regularly override the OS thing so I can run Linux images. Does that answer your question?
to a large extent, yes.
OK. grab me afterwards and we'll go into any gaps.
So one more.
Yeah.
So in terms of like splitting or providing the images, right, and what you should put in.
Yeah. Yeah.
So why it would be a bad idea to put like individual libraries into separate images? So if I have like an Nginx,
Right.
the Nginx can be built only with like libc, libcrypto, libssi, and that's it.
Yeah. So the question is, what are the downsides of making images? If I understand it, individual libraries in individual images. You end up with a lot of layers. So there's a computational cost of combining the layers. So there is a definite trade-off there. Absolutely, it would work if you did it this way. And assuming those things did not conflict in any way, that weren't touching the same parts of the file name space, you can layer them quite easily. But there's a cost of composing the layers. So I usually use ZFS for storage. So each of the layers, each layer is applied on top of some other layer. Okay. To do that, we take a snapshot, we clone the snapshot, we mount the snapshot, and we unpack the new layer into that. And that gives us the next part. So you end up with a lot more ZFS data sets. But maybe that's not a problem.
Horizontally, not vertically. Vertically, just add on one layer.
Right. Okay. So, but the paradigm that. So let's look at the next slide here. So these are applied in a strict order, and that's just the model that they took. We could certainly. I could imagine just changing the order, but there's still got to be an order that they get applied in, and that's if we step outside that paradigm, that we don't have a single vertical ordering, then I think a lot of stuff is going to break. It'd be a lot more work. You can certainly start from scratch. You can start from the empty image and install whatever libraries you want. Package-based makes that fairly straightforward, and that's how I get started with package-based. I start from.
But you have to go vertically, right?
Yeah.
Each library after each one.
But each layer, I mean, if you're building them, supposing you're building the ideal base image for Nginx that's not going to support anything else, right? You can start from scratch and insert the exact packages using package base into that empty directory, and make a tailored base image for your workload. That's absolutely fine, and that will work. And maybe that's exactly the right answer for certain specialized problems. But just let me complete this thought. I think that we can't supply all of those carefully handcrafted base images for all the possible applications because we don't know what those applications are. So, question?
When you're creating an image, you're not creating one layer per package installed. You install a bunch of packages and then you create your layer, right?
So the question is, when you're creating an image, you don't create layer. You create a new layer by installing packages into that layer. Yeah. Yes, that's exactly what we do, and that's how my tools work. So typically, there's a main package I want to install, but there's usually a couple of extra bits and pieces that package needs. So I might install FreeBSD runtime, maybe a couple of extra libs that my gut feeling says are going to help support a bigger class of applications. And that becomes one layer. So it's going to contain more than one package-based thing. Yeah. So where did we get to? I think we were near the end anyway. So building, so we're distributing. OK, let's talk about verification. That's an important step.
So we have one question from online. Someone asked, is it OK to have the same, like FreeBSD in multiple registries?
Absolutely.
OK.
So if you put, and I do this already, So I put my test images in Docker Hub and it's in Cray. The reason I started doing that is because the rate limits on Docker Hub are more restrictive than Cray. So, and yeah, if you're logged into, it's not usually a problem for me, but if you're not logged into Docker Hub, it's pretty draconian about shutting you down once you download a few bits of stuff from them. Anyway, yes. And in actual fact, if I download an image from Docker Hub, and then the next day I download an image that was built from that happens to be stored on Cray, the hashes allow it to only install the new layer. It doesn't have, because it knows the hashes on Cray will be the same as the hashes on Docker Hub. Because when I push them, that's the data that I pushed, and it's not allowed to change that. So it can download just the delta. It doesn't matter where the original base was downloaded from. So, verification. If we distribute our, OCI archives on download.freebsd.org, we can put checksums next to them. This is what we do for most of our release artifacts. Whenever we build a release, the area on the release area on download.freebsd.org contains a manifest that has the checksums of all of the pieces that we're releasing. So we can put those checksums in, and that's pretty much how people tend to trust FreeBSD releases now. And this is how most people trust images in the Linux world. Most people don't use image signing. People use trusted registries. Docker Hub's been around for a long time. They haven't been hacked, at least not that I remember. They haven't done something stupid like modify people's images. So people trust them. And they even have an infrastructure of Docker verified images, where they have a public build process that can be triggered by new releases of a piece of software that it will run. It would build an image based on some Docker file that's been supplied to them by the vendor, and apply this, put this in the Docker Hub registry, and put a check mark on it to say, we built it, you can trust it. And people do. I mean, we could apply a subset to that if we ran our own registry. If the only people that can push new data to registry.freebsd.org are the release engineers, then it's a reasonable step for most people to trust that images that they download from registry.freebsd.org are official ones. And that's how most things actually work in practice. But there is a concept of signing images, and there's a lot of flux here. There's a lot of research on what the best way of proving an image or a collection of images is the one which you wanted, the one which you believed was correct. Red Hat implemented a system using PGP that when an image is pushed to a registry, at the point of push, it knows exactly the hashes that are being pushed, and it can locally create a signature based on a PGP private key to create a signature of the manifest, just the manifest of the thing being pushed. And that's secure because the manifest refers to other data, but it refers to them by hash. And unless you can crack the SHA-256 hashes of the things being referred to, it's going to be really hard for you to break that. Maybe SHA-256 isn't big enough now, but we can change the hash if necessary. So that's how it works. I push the image. I push it in my config file says, hey, sign. Oh, no, actually, there's a command line flag. So I push it with a command line flag that says, please sign this as well. So it signs signs the manifest and stores the signature locally. And I can then, as some sort of administrative step, make those signatures available. And it's typically done by publishing them to an HTTP server. They tend to call it a look-aside server because when you're pulling an image, you look aside to get the key from somewhere else that you trust. Again, this is trusted perhaps because you're downloading signatures from Red Hat to verify Red Hat images. And so you set up your config locally to set up a look-aside server with the address that Red Hat's told you is the trusted place for signatures for Red Hat images. This actually works. I looked into this. I implemented it locally. It does work. Only Red Hat supports it. Containerd people don't want it. So it's not the full solution. Sigstore, actually Sigstore covers a lot of ground. But originally, I think it started by trying to do the same thing, but with X509 keys. So you build a public key, private key pair with X509. On image push, you sign with the private key that's available locally. And you push the image. And this time, we also push the signature. So the signature can be pushed as an object in the registry. So it's stored alongside. And they have a naming thing, so that it's kind of named with the hash of the thing that it signed, something like that. I don't want to go into the details, but it does kind of hang together. So the image got pushed. The signature was generated of the stuff that was being pushed. And that signature is also pushed to the registry that you were uploading to. And then verification for look-aside, we talked about that. You download the signature from the HTTP look-aside and check it against the data you downloaded. With Sigstore, you do the same thing, except that you download the signature from the registry that you're trying to pull from, using a rule to create the name of the signature so that you can know what you're downloading. So and this all happens automatically. Then you can verify that somehow. Sigstore in this early stage doesn't do key management at all. But what I can do is perhaps install the pub key of the organization that I want to trust and check against that and set up my configuration to, when I'm downloading from registry.freebsd.org, I will verify against this pub key that is stored in my local file system. Yeah. The question is, how reproducible are image builds? That's a really good question. I tried really hard to make them reproducible, but package-based fought me. So I can make the contents of the image, apart from the package-based metadata, reproducible. I can force the timestamps of all the files in a layer to be a predictable value. Like, for instance, the date that the patch release was cut. And the ordering as well? And the ordering of the layers is consistent. But package-based uses SQLite to store its metadata, and SQLite doesn't like being reproducible. It had timestamps in the logs. I managed to force the timestamps, but they still were not reproducible, and I got stuck. I couldn't figure out what to change. If we nuke the SQLite data so that we don't have the package, we don't have a log of what was installed in that image, then we can make them reproducible, but they're less useful. So there's a trade-off there. That's a great question, though.
Because for me, there are like two attack vectors that are often going to me. For example, repeat my questions.
Okay, so I think that there are two attack vectors that are often overlooked. So one is reproducible builds, right? So even stuff like ordering the files in the tarball timestamps, as you mentioned, right?
Yeah.
So this would protect us from or I can, as someone who consumes FreeBSD, verify that this source code was used to build this. So this has to be easy. I have to be able to verify that independently.
So,
right? So
if we look at it from the model of the way that the images are signed, we're signing the image manifest. The image manifest refers to those layers by hash. So if someone changed one of the layers to do something nefarious, the hash wouldn't match anymore, and you could not you can't download the broken image.
I mean that an actual Colin will agree
Yeah,
with
yeah,
me
it's
that
a murky.
during our release process, if
right.
there is something malicious in our infrastructure, right?
Right.
So that's one, and the other attack vector is that if someone can publish the image secretly, so it won't be published, like I can force someone to download the image and it's built by our infrastructure, but it's not published somewhere else. So I want to like target specific victim, right?
Yeah.
So, but for this, we would need something like certificate transparency, but for binary builds. So if we build an image, we also like publish the image somewhere else.
Yeah.
And then somebody who downloads the image also check this somewhere else.
And I'm not an expert, and I'm kind of just been reading about this recently. So Sigstore is an evolving project, and that's one of the directions that they're evolving towards, where a developer builds an image and uploads the signature to a trusted log. It's an append-only log, so that you have some trust there, that you can verify the root trust certificates of that log, and users that are downloading the image can check against this log. So, yeah, this involves buying into the trustability of the infrastructure being supplied by the Sigstore kind of group. I think it's possible to run. It's possible to run this locally. It's all open source, but there's some two major components. One to right, yeah.
We don't want this to be part of FreeBSD infrastructure.
Right. Okay. So yeah, this is something that I talk about. This is the line cosign that adds keyless signing. This is part of that. I'm not an expert enough to know whether it solves the problems that you described, but it's certainly something worth looking at. Okay. Next steps for FreeBSD images, like we talked about before, try and add some code to source release to get the ball rolling. Wait for Colin to finish doing 14.1 so that we can kind of work on some of that stuff. Figure out how the build cluster works. It's very murky to me. I don't even know where the code is. So I'd like to understand that a bit better. Yeah, figure out what the best way of publishing images that we're all collectively happy with and feel like can be trusted. What I want to get to is that you people trying to use, perhaps people coming from Linux that we've sold them on. FreeBSD is an alternate version of a viable alternate for Linux. We talked about that showing up as a meaningful thing in the survey. They're going to expect some of the tools that they're familiar with. People use Docker all the time to run stuff. It's really great. You can download the image that's got the right tool chain for building the thing you want to build. You run the Docker file. It all just works. You don't have to debug the tool chain and things like this. And yeah, I'd like people to have that experience on FreeBSD. The first step is to be able to download an image. So I think we should help with that. That's all I've got. Any more questions? John?
Yeah, I'll relay it.
Okay.
Especially out of line. So just to be clear, this is running FreeBSD jails on a FreeBSD host in essence.
Yes.
But do you also run, like, when you mentioned Linux earlier, is that using a VM? Is it using a jail?
So when I run Linux images under emulation, I just use FreeBSD's built-in Linux emulation. It works well enough to support most things that there are images out there that we will never be able to run because they require magical things like C groups v2 or some NVIDIA driver that we don't have kernel modules for or whatever. There will always be images that we can't use, but our emulation works well enough to run Linux stuff, and it works surprisingly well. For running different architectures, QEMU works pretty well. I still need to tie up some loose ends with Warner. Now that we're in the same time zone, maybe we can get that done. So to make that easier, but you can inject the right QEMU static into an image when you run it, and it works.
We can run QEMU jails right now.
Yeah. Anyway, one more question up at the top there.
So what's resource management like in terms of limiting your container to running a certain amount of cores, a certain amount of memory, that kind of thing?
That's a great question. So we have some infrastructure to support resource limiting. So RCTL, is that right? Yeah, RCTL is a system for restricting access to resources for some domain. And that domain can be a jail or a process, or maybe a process group, I'm not sure. So we can absolutely use that. I've not implemented this. And this is something which we're going to try and work on standardizing as we define what an OCI runtime for FreeBSD should do. But yeah, so the answer is we don't do anything, but we know what we want to do. Okay.
I work on ZFS, and I was just, do you have any particular thoughts about what more ZFS could do to support this? So it's good to see you've already, using cloning and everything to build that like that. Obviously
Right.
makes sense. One thought is simply can a snapshot be be the registry kind of thing? Like, could I replicate images to other machines? Is that useful? Are there facilities that you thought, oh, if ZFS could do that,
Yeah.
that'd be gold? What do you need?
So the part can ZFS be the registry? It actually can. I mean, so Podman's storage layer, it unpacks the layers and applies them locally at pull time. And if you're using the ZFS storage driver, that's exactly what they do. They create all the right snapshots and do the clones and things. I think Containerd might be a bit more complex. I think it might only unpack things on demand. But again, it uses, if you're using the ZFS snapshotter, then it uses ZFS in the same way to clones. The one feature which ZFS kind of already supplies that I think we could use is diff. So when I'm calculating what the delta layer is for some container that I just run, maybe I'm creating a new image layer. It's kind of brute force. We take the two trees and we diff them, right? The ZFS can help with that. It already can do this, but I don't think anyone's tried to do it. Yeah. More questions?
Just wondering, Doug, if you want to show people the link to the GitHub repo for the working group or the Slack to get involved?
I'll put it on the Slack.
Okay.
I'll put it on the Slack. Yeah. No more questions? Oh, one more.
You're not getting off any. Sorry if you mentioned this already and I missed it, but what's the privilege model when you're actually using Podman to start up containers? Do you need to run it as root, and then what privileges do I actually need to access it in
Right.
general?
That's a good question, and I meant to point this out, but yeah, we have to run as root. We don't have a mechanism of being able to run rootless containers. The way things work under Linux, I mean, I'm talking about jail-based containers here. The way things work on Linux is they have something called a user namespace. You can carve out a UID range and then map that to an unprivileged user on the host. And that works well enough to run quite a lot of workloads in an unprivileged way. To get there, we need to do quite a lot of work, and we haven't done that work. We could run, if we had unprivileged Beehive, that sounds exciting to me. We could do stuff in a Beehive VM. Does that answer your question?
Yeah. I guess. I can guess at some answers to this, but why exactly does jail create need to be a privileged operation?
Well, that's a good question. I don't think I can fully answer that, but I do know that mostly I run root inside the jail. And I know it's a restricted root. I know that jail applies some restrictions. But I think that the trust level of how strong those restrictions are is probably what's guiding us to make creating a jail a privileged operation.
One risk would be that jail, the root, have more privileges than unprivileged unjailed user.
Sure, but creating a jail and attaching to it are two different things, right?
Can we try and get some of this onto the recording?
So I just wanted to clarify that, like, I'm talking about creating a jail specifically and attaching to it a separate operation. So I mean, attaching to a jail as root in the jail, I would expect to require root privileges on the host.
Can you easily create a jail without dev?
Oh yeah, you need a dev mount.
I think Colin might have an answer for us, or another question.
If you can create a jail as non-root, then you can do nasty things with setuid binaries. But the security problems more or less go away if you create a jail that has setuid disabled, which I think we have a feature for just easy to turn on with the sysctl.
Because as user enable system.
Yeah, that one.
But this is what I meant. That, if you can create.
You can all come down to the front, maybe.
So this is what I meant. If you can, as an unprivileged user, can create a jail, I assume you control the content of the jail. So it can contain setuid binary. So basically, you can control the root inside the jail. And I think it has different set of privileges than unprivileged user outside the jail. So that would be the escalation.
Yeah, but I think there's also, we've certainly had people being able to exploit their way out of jails and to break.
Yes.
So if I imagine as a non-privileged user creating a jail that allows a root process to run inside, I feel like I'm enabling that risk for something I don't have the privileges to make that choice.
But I will give you a better answer, okay? So what we would really like to do is to be able to have something like Cloud ABI, if you remember this project. So this was actually an awesome response to this problem. So not only you can create small containers, the container can be like a single process, which has no access to global namespaces. And you can chain those containers together and be able to like connect them together, right? So if we could support this, so we could have Beehive as a full-blown virtual machine, we could have jails, and if we could have like single process containers or like group process containers, but with no global namespaces, right? That would be, for me, it would be even better, right?
Okay. So we are almost out of time. So I think we should stop here. Unless we have any more questions that can fit into 3 minutes.
Okay. Well, thank you very much, Doug. So we have a break for 30 minutes. We'll be back in here at 3 o'clock. back to our seats and get ready. This will be our last session of today, this afternoon. So a couple of quick things before I hand it over to Mitchell here. We did get the shirts in between lunch and the break. So if you haven't gotten your shirt yet, you can come down and get a shirt. They're sorted by size, small, medium down here on the table. Large is at the end of this table, and then the extra large size is next to that. So next up, we're going to have Mitchell talking about RISC-V, and then following that is on the schedule it says TBA, when I'm finally able to do the A part. After Mitchell, we're going to have Sven Rudiger talk for a few minutes about a topic he showed me that he has. And then finally, I'm going to have Warner come up after that, and he'll give his pitch about some possible, his thoughts on bylaws to kind of get the juices flowing before we head to dinner. And then at dinner, we can have more animated discussions about that topic over pizza. So let me hand it over to Mitchell, who's going to talk to us about FreeBSD on RISC-V.
Okay. Thank you, John. Hope you all can hear me and see me at home. Hi, my name is Mitchell. We're going to be talking about FreeBSD on RISC-V today. I'm a FreeBSD source committer, Canadian. I live in Halifax on the East Coast. So honestly, a shorter journey for me to get here than most of you. But this is my first time at BSDCan in person. So I'm excited to be here and meet you all face to face. I spent about a little over the past 5 years working on FreeBSD RISC-V in some capacity. I kind of began hacking on it when I was still in university. It was like a good way to work on something that taught me a lot about different aspects of the kernel and kind of low-level programming. Since then, I'm very grateful to have been sponsored by the foundation to continue to work on this, and that has, paid my rent in the past couple of years. And so, I'm kind of looking at this now with 5 years of kind of perspective on this architecture and this platform, and so I hope to share that with you guys today. The goals for this talk, so we're going to explore kind of the health of this platform, or how does it look now and where is it going compared to, I did speak at the Dev Summit in 2021 that was online, and we kind of did more of a history. So this is going to be not super technical, somewhat informal. Hopefully we'll have some time for discussion. We have an hour and a half, and I don't want to talk quite that long, but I do have more slides than I thought. The agenda, basically, we're going to do a quick overview of some RISC-V hardware that exists today. We're going to talk about the challenges of supporting this hardware from an operating system point of view, the status of ports and packages on FreeBSD and FreeBSD RISC-V, and kind of what comes in the future. So yes, we'll do a little tour of some hardware that is kind of exists now for purchase or is upcoming. As John referred to it earlier, SAND, which I particularly like. High5 Unmatched, this is kind of our reference platform for FreeBSD RISC-V. So we fully support this hardware that was kind of first came out a couple years ago. Thanks to Sci5 for, they are essentially a RISC-V IP company, but they have they've kind of pushed the envelope with producing hardware to stimulate the software ecosystem. So, so yes, they've formed themselves to be a reference platform of sorts, and they provide good documentation that has allowed us to port to this platform fairly easily. And I would say this board is not interesting in the sense that it just works out of the box. It's not particularly performant, or it doesn't have any exciting hardware or software features, really. But it is available, and if you own one, if you happen to own one, or you happen to buy one for $740, you could run FreeBSD on that today. Vision 5, version 2 is a single board computer that we're kind of in the process of doing bring up and upstreaming of support for that. So we have, as of the last couple of months, the clock and reset drivers, the MMC SD card, and the serial console are all working. We have a port for their particular flavor of U-boot, so you can follow the instructions on the wiki to, oh, maybe they're not quite updated yet, but soon you'll be able to pull the 15 snapshot and flash it to an SD card and at least boot on this, but there's no Ethernet yet. That's kind of the next big step. Documentation is decent for this board, but not quite enough. There are several devices that are just not, they're not adequately covered by the data sheet, and so we're kind of faced with this problem of how do we create drivers for these. It also has an onboard GPU, which maybe someday will be covered by upstream Linux graphics drivers, but I'm not really sure about that. This is another board that came out a couple years ago, the Allwinner D1. This is another one that's kind of in progress. I own one of these and I have been playing with it. There is a U-boot for it, but it doesn't seem like the vendor is trying to get that into upstream U-boot. They just kind of have their fork, but it does work. The Hi5 Premier, I guess, is kind of the next announced platform from Sci5. So based on the previous Sci5 hardware, we can kind of expect that FreeBSD will run on this without too much effort. We will see. Supposedly it will be available soon, but I couldn't find any information on that really. You can check out the product page. I was going to upload these slides to the Dev Summit page, and I forgot to do that first. I do have some links, but you'll have to wait. Milk 5 Pioneer, I find that to be a disgusting name. This is an announced platform. I don't think it's quite available for purchase yet. So it has the T-head system-on-a-chip, or Xuantai C920 CPU. So kind of the same underlying CPU architecture as the Allwinner board, which we're going to talk about more. Yeah, essentially this comes as like a micro ATX form factor, and they're selling it as a whole PC, make native RISC-V development possible. You know, this is a bigger machine than we've seen before, so supporting this might be interesting. And it has all the kind of peripherals that you would expect from a PC. A few other single board computers of interest are listed here. We're going to not talk about these too much. Banana Pi is one I just heard about, and it has a CPU I've never heard about, so I can't quite comment on how difficult it will be to support that. But the others have the same T-head system on a chip underneath them. Hopefully that was clear enough. Next, we're going to talk about the kind of software side challenges of supporting the RISC-V architecture. So quick recap, RISC-V has RISC-V CPUs have 3 privilege levels: the machine mode for firmware and bootloaders, the supervisor mode where the kernel, FreeBSD kernel runs, and that has virtual memory features, and user mode for user space applications. The supervisor mode where our FreeBSD kernel runs has somewhat limited capabilities. It can't read, every system register that machine mode can, in a way that's like a little more restrictive than other CPU architectures. So they've come up with this thing called the Supervisor Binary Interface, SBI, which is essentially a firmware runtime you can call into from the kernel and have it perform different tasks for you. So for example, RISC-V does not have it does not define any instruction to perform a remote TLB shoot down. So you have to call into firmware to get it to do that for you, among other things. And they have a specification for this, and then OpenSBI being the kind of standard implementation of the interface, and they keep adding new functionality to this, sort of as a way to mitigate what is missing from the RISC-V instruction set, which we're going to talk about here. So initially, in kind of the early and recent versions of the RISC-V architecture, they did not specify any cache management instructions, so no way to flush or validate the data cache. They didn't define any page table bits to declare the kind of memory type or properties of the page you're talking about. So you couldn't say, this virtual address mapping is for device memory, or this virtual address mapping should not be cached. There was no way to specify that, and there were no requirements on I/O coherence with respect to the CPU. So, unlike I believe x86, device I/O is always coherent with respect to the CPU data cache as part of the instruction set architecture. But RISC-V, they said, no, we want to keep it open. We want to allow implementations to essentially decide that for themselves. But they didn't provide any way to deal with such a thing. So the first thing resolved in a later specification. So they have defined a set of cache management instructions for RISC-V, but you won't find them in any hardware that exists yet today. And same thing with the page-based memory types extension. It does allow you to specify attributes on virtual memory translations. And this is, it's defined, and you can work with it in QEMU, but it's not, again, it's not in real hardware, really. Consequences of these problems, this kind of lack of specification when it comes to cache coherence. For the Star5 boards. So as I said, we're working on upstreaming the Vision 5 version 2. The original prototype was called the Beagle 5 Starlight, and then they shipped that to a few FreeBSD developers, and then Beagle 5 is now no longer involved with that. I don't understand. And then they did another prototype, the Vision 5 version 1. Both of these had non-coherent device memory with respect to the CPU. So it essentially required a kind of hacky workaround method in order to talk to device driver. In order for device drivers to talk to device memory properly, we had to use this workaround. For this reason, bring up on these platforms was a failure. Star 5 upstreamed a bit, and then they kind of stopped. I worked pretty hard to try and bring FreeBSD up on these, but because the upstreaming wasn't quite complete, among other reasons, like non-coherent device memory being really hard to work with and debug, it was bring up failure, and I have 2 new paperweights. Yes, and a few other people. Other consequences of this kind of poorly specified, these poorly specified aspects of the instruction set for these T-head system on chips. They said, okay, well, we need page-based memory types, so we're just gonna make it ourselves. We're gonna define it ourselves, because we're ready to produce chips now, but you haven't defined this in the instruction set. So they did, and sadly, it's kind of in a way that violates the specification and not in a compatible way. So essentially, the kind of default behavior. Normally, these high-level bits and these higher bits in the page table entry would be set to 0, and ideally they would have done it so that had kind of no effect, but they didn't, and so it's going to require some work to support this if we want to support this spec-violating hardware. They also implemented an early version of the vector extension, so that's an extension to the ISA, essentially like SIMD on AMD 64. But again, they did so it wasn't quite fully ratified, and so, but because they were ready to produce hardware, they just went ahead and did it. So it kind of presents another problem when it comes to an operating system asking ourselves, well, do we want to try and support this thing that is different than what the specification says? Based on the available hardware, so I know we went through the overview quick, but at least 3 or 4 of those systems have these T-head system on a chip. So it's essentially the most accessible RISC-V hardware available now. So to me, it seems clear that we do need to try and support this. Maybe not the vector extension, but at least we need to be able to boot on these, and that requires some work for the page-based memory tables. Yeah, so there's kind of foundational changes to the PMAP that are needed. Really early boot workarounds and working with the bus TMA subsystem. Not to mention because they didn't define the cache management operations early enough, T-head SoCs also define their own instructions for that. So there's a lot of work to be done to support these CPUs, and all that's before you can really take on trying to implement device drivers for a particular system. So that's why we only run on really Sci-5 hardware so far. Another example of the RISC-V architecture's kind of failure to define itself was in the performance counter space. So the early specification of this, they said, okay, well, there's going to be 32 hardware counters. It's up to the implementation what events it measures, if any, and what the encoding is for that. And these registers are only accessible by the firmware privilege level. So when it comes to implementing like HWPMC and libPMC, the performance counting facilities, the CPU architecture hasn't defined it well enough that we can even do that. So how they compensated for this? Well, we added an extension to the SBI so that you can manage these registers, and it'll kind of handle all the differences between a particular CPU's implementation because it's implementation defined. To do this, they provide a kind of hard-to-use interface. They end up defining a list of event codes anyway, and it has a high cost because you have to trap to firmware just to set this up every time. And it seems overly complicated compared to if this had just been kind of defined more thoroughly from the start, which I think is it's a disappointing reality when you are when you're trying to support RISC-V from the software side. Also, they've defined this, I'm not even going to try to read it, this extension that it adds the ability for counter overflows to generate interrupts. So if you want to use PMC stat in sampling mode to measure where your application is spending time, that requires these overflow interrupts to essentially interrupt at a regular interval. And because this is not defined as part of the base ISA, even with the PMU extension fully implemented, what you can actually do and measure on the unmatched board, for example, is not very it's not very useful. And why did these failures happen? The spec is written by committee. The RISC-V ISA has tried to create this kind of open source model for a CPU architecture. And so it suffers from the problems that all open source projects do. And they also, in my opinion, kind of try to define it so broadly that RISC-V could be implemented from the tiniest to the biggest CPU. And it's just hard to have things done right and completely when you want to do everything. In general, sorry, let me catch myself here. In general, if you're trying to bring up FreeBSD on a new single board computer, such as the ones I listed, like any of the upcoming ones, you're going to face some challenges. And for RISC-V, they're no different than kind of the existing embedded boards we have for ARM and ARM64. So you're at the mercy of the vendor for how much they're willing to push upstream. So in the best case scenario, they upstream support for their hardware to Linux. they upstream it to U-boot, which we rely on heavily, and they'll upstream it to the OpenSBI firmware as well. And if they don't, like, that makes it harder, if not impossible, for us to support it as a hardware platform. And in the same sense, you're at the mercy of how much documentation they give you, because if this new board has, you know, an Ethernet chip that we don't have a driver for, or maybe it's like a little bit newer version of the chip and we need to support that, but they don't provide any documentation on what it is, how it works, you know, you don't have a lot of choice. You can, depending on your disposition, look at the GPL Linux drivers, but you're you know, getting into a gray area there. And SOC bring up in general is painful work. So it's a challenge when it comes to, you know, people are interested in this emerging architecture. They want to see RISC-V run on these new toys. And they say, oh, do we support this? Do we support this? And you know, the answer is no for any number of these reasons. Okay. My work, what am I working on? So the PMAP improvements required to support the T-head system on a chip and CPUs, that's kind of something that's, it's going. I've been working on that lately. I have some stuff in Fabricator that's kind of preliminary to that. But I want to get this foundational work to support these CPUs in, because then it enables us to even kind of start to do SoC bring up for them. The PMC facilities, as I kind of talked about, like the current state of affairs, it's not, I have a mostly complete implementation. It's not super useful for existing hardware, but I would like to complete it and kind of see, mainly so that when this stuff matures a little bit more in a few years within the spec, that it'll already be there, or at least mostly be there. And then the Vision 5 version 2 upstreaming, that's kind of another active project. And then the kind of immediate roadmap of things I want to take on but haven't started yet, supporting EFI runtime services in the kernel. So we boot via U-boot, which has an EFI interface to boot the FreeBSD EFI loader, but you need some extra stuff to use the runtime services from the kernel. Same thing with kernel, FPU, context. So I think every other architecture supports this now. This is essentially, you know, within defined areas, being able to use floating point instructions and registers within the kernel. So it's not too much work to support this, and it will eventually be useful for in-kernel crypto drivers and GPU drivers. Also, in the works, Ruslan has begun work on RISC-V Beehive. You know, there's not too much more to say than that. He's started, and you can ask him, but you know, it's going well, essentially due to the simpler hypervisor architecture compared to ARM64, and also thanks to the long efforts to bring ARM64 Beehive into reality, which did the majority of legwork to kind of deduplicate and deduplicate Beehive. So this is something that supporting the RISC-V architecture, we're able to do a lot is kind of piggyback off of whatever ARM64 has done. It's probably structured in a similar way here, so we're not going to reinvent the wheel, and it makes our porting efforts easier, which is a win in terms of maintenance. Okay, I went really fast, so let's catch up. Any questions or clarifications so far? Yes. Do we?
You mentioned GPU IP intellectual property. Is that from inside the RISC-V project or outside and brought to it?
Outside.
Can you name from where?
So you're talking about during the hardware overview? Yeah, it's. I don't know the details of it. It's called Imagine is the name of that particular GPU.
Have you spoken to anybody that did the initial porting to ARM v7 and ARM v8?
Not really.
Okay, might be worth doing that because there's a lot of deja vu to me, and I'm coming from the ARM side of things. So
yeah,
that there's. I think you may be cutting yourself on sharp bits that people have already blunted in other areas.
So like the coherence problems, or what were you thinking there?
More the actual bring up aspects, some of the U-boot pieces, some of the driver issues that you're running into and how they got round.
Mm-hmm.
A lot of those pain points we definitely did back in the day, and so I think you may, as part. I mean, I get why you've gone down it yourself, and because you want to learn and whatever else, that all makes sense. But to lessen the pain, you don't need to go through pain unnecessarily. I think other people may have experienced some of that, might have been able to help you a little bit.
Yeah, I mean the folks who have done bring up on ARM within FreeBSD are aware that some of these pain points kind of still do exist for FreeBSD specifically, right? Where when it comes to how much is the vendor giving us, in terms of documentation, that's not a solved problem for them either. Is kind of the parallel I'm drawing here. But thank you. If nothing else, then we'll keep going. Ports and packages. So native package building, not really an option yet because we don't have hardware, we don't have beefy hardware, which is really what you need in order to start producing packages regularly. Obviously, as we know, building packages natively is the kind of, that's the least error-prone way, right? But since we don't have this, we're kind of, we have the second option, which is to cross-compile packages with Poudriere and QEMU user emulation. So this has been done before for ARM and MIPS and maybe others. So this works a bit. We can, with the older version of the, what is it called? QEMU user static package, version 3.4, you can build a fair amount of, you can build a wide range of ports before it runs into any kind of problems. But with the newer versions, it fails right away. So I know Warner has done a lot of work to kind of bring that up to speed and upstream a lot of our changes there. I think to get past this, it's probably not, there's probably not that many bugs that are hiding in there, but I don't really know how to debug it. I haven't gone into that rabbit hole of how to save the state of Poudriere and then start debugging the user space emulator. For anyone not familiar with this method, essentially, we use QEMU not to emulate an entire system, but to emulate the system call up to the system call interface so that you can run RISC-V, for example, RISC-V programs on an x86 machine, and we kind of trick it with a cross compiler. So we go in, we create this RISC-V architecture jail in which we build our packages, but it's done on an x86 machine. So in order to get anywhere new with ports and packages on RISC-V, we need to make progress with this. A couple of years ago, I think these are the right years, there was kind of an experimental run of RISC-V packages where we were using this cross-compile method to build packages regularly. So that was in FreeBSD 13 era. Port manager or whoever was running that did that for a while, and then they stopped. So for the past couple of years, we don't have any packages available in the official repos. So if you boot up FreeBSD RISC-V in the emulator, or you run it on real hardware and you say package install, it's going to tell you, well, there's nothing. There's no bootstrapped version of package that exists. And I don't blame them for dropping that. It wasn't super coordinated. I know it was an experiment and probably required a lot of babysitting. So this is an area that I think, parallel to being able to run FreeBSD on these kind of newer RISC-V hardware, parallel to that, we want to be able to start building and providing ports and packages so that you can do more interesting things on these systems. In general, there has been some work done to kind of help fix ports that either don't build or are marked broken on the RISC-V architecture. There's a list that's not really maintained here that kind of has the per platform list of supported programming languages. So on RISC-V, we have C and C++ through LLVM and GCC. Of course, we have some scripted languages. The kind of challenge was with compiled languages such as Go and Rust. So these languages, rather than using libc, they essentially use the raw system calls and provide that themselves. And they were both stuck using a much older version of the FreeBSD system call ABI. So, I believe Go and definitely Rust were they were both using the FreeBSD 11 version of certain system calls, the pre 64-bit inode versions, and the RISC-V architecture the RISC-V platform is new enough that it never existed for that release, and so we don't provide it. So it has been a bit of a fight, especially for the Rust one, of FreeBSD developers telling the Rust or the Go developers, hey, you guys are using you're using the ABI of an unsupported version of FreeBSD. You need to bring this up to date. So I believe it's finally, they finally moved past that on Rust. They finally stopped using the FreeBSD 11 and 10 system calls in favor of FreeBSD 12 system calls, which is really great because that's also unsupported, but it at least should unblock this for the RISC-V architecture. So being able to build Rust, provide Rust as on this platform was blocked for a while. Now it's kind of open for someone to investigate. As I said, Go had a similar problem that was solved last year, I think. So thanks to everyone who worked on that. Java, if you can believe it, nobody has asked me about it. Any questions here or even thoughts or comments on ports and packages?
Do you know if you crank up a chroot jail, if that works with RISC-30 or RISC-V64?
Can you say the question again?
Yeah, if I do a make install world of a RISC-30 or RISC-V 64 build and start a jail up with that and try to launch QEMU, does that work or does that seg fault right away?
It works. Who's building and doing it?
I didn't quite hear.
That was Colin saying that the release engineering is doing it.
Great.
Right. And the system calls that don't work, do you have a list of those?
No. So I've basically done the Poudriere, like I've used Poudriere from the command line to say, oh, I want to build these packages and set up the newer user emulator, and it seg faults, and I don't know how to look into it further.
I'll look into that. I have a student this summer who's upstreaming ARM-V, I don't know why I want to say ARM-V, ARM64 support that we have in the Blitz branch to QEMU upstream, and was then going to do RISC-V. And I don't want to handhold them through the whole summer with things that don't work at all, so I'd like to kind of fix the stuff beforehand while I have some time.
Yeah.
While they catch up to me.
Yeah.
So I'll try that out.
Okay. We can chat about that too, because it's...
Yeah, because it's, from what Colin's saying, it kind of works. And then there's something in Poudriere that goes off the rails, which is both a blessing and a curse. It means that we may be able to get that unstuck too.
Yeah. Yeah, I think it's probably not something too deep that needs to be fixed, probably something small, but there's been, for me, I haven't had the time or know how to really approach it. Other questions or comments? Great. Okay. Platform viability. So I don't have too much left, but in general, I want to kind of open this discussion about, what's the current viability of RISC-V 64 as a FreeBSD platform? Like, where are we? Where are we going? What are the major blockers? So what works today? We have a maturing base system. We've had 2 major releases, 13 and 14, with RISC-V as tier 2. And I would say it's feature complete in the sense that I don't think there's anything major that is marked broken on this architecture anymore. So from the point of view of the base system, it looks and behaves just like any other architecture that FreeBSD supports. Of course, there are questions of hardware and more esoteric kernel features that will need to be implemented, but yeah, this is a milestone. I would say that is worth celebrating. Is the state of the base system is in good shape. CherryBSD. So without speaking for them, who I'm not part of that project, but CherryBSD was the original motivation for the RISC-V port in the first place, and now we have seen that RISC-V has grown enough. Cherry is able to use it, and MIPS is gone. So, hallelujah. So that works. That's a point in the platform's favor, and kind of an indicator of its current usage and health, shall we say. We benefit from developments to other platforms. So like I said, the porting effort for certain things, whether it be, like upcoming Beehive or, PMAP improvements or any other kind of major developments that we see on the tier 1 architectures, we're able to kind of benefit from those who've come before, which is another point in favor of this platform's viability, because it helps reduce the kind of maintenance of it. What else? What else can we say about this platform today that is a point in its favor? Does anyone have a thought on that?
Well, I guess one point. So one point relative to MIPS in particular. There we are. Anyway, so yeah, one point particularly relative to MIPS is that because the port was basically started by copying the ARM64 tree, it is not a weird outlier.
Mm-hmm.
It doesn't. If we had to support arbitrary numbers of weird cache management schemes, that would be a point against it. But fortunately, we're eventually, curving towards something that's usable.
Mm-hmm.
So I think it's important for a tier 2 architecture to not be weird.
Yeah.
And like the burden of all the weirdness needs to be on the architecture maintainers. Like Power is failing at that in a number of ways at this point. It was a problem with Spark.
Yeah.
There were things that were unfixable. MIPS had these problems. So I think RISC-V is nice at the moment in that it is not like a big outlier relative to the others. We have limited hardware support, obviously, and that sort of thing. But at least like the software is not just strange.
Yeah. Yeah. Thank you. That's a great point. And it seems to be the kind of general intent of both the RISC-V ISA, like the instruction set architecture itself, and the kind of platform level specifications. They're saying, okay, we're trying to do things in we're trying not to do things in weird ways. We're trying to use existing technologies or specifications such as EFI, ACPI. Even the platform level specification, which I unfortunately didn't really include in this talk, is kind of based on the ARM platform level specification as far as I know. So yeah, that seems to be part of the ethos is let's not reinvent the wheel. And from the point of view of FreeBSD's support for it, we're not trying to do that either, which is a benefit. Immediate problems with the platform, lagging support for current hardware. So yeah, out of all that we looked at the beginning, maybe, what was that? 7 to 9 different system out of chips that we don't support. So we need some kind of foundational support for some of these weirder these weirder CPUs that are out there, and that's stuff that I'm working on. But even with that, bring up is still not easy. It's still a difficult job. So yeah, we could use more hands for hardware bring up. And no ports of packages being built right now. So yeah, we need to fix the user emulator, and we need to work with Port Manager to kind of get that process started if they feel it is something that will be worthwhile. But I would say that having no ports or packages and not being able to build them very easily, from the point of view of someone kind of evaluating this platform in its immediate state, that's a pretty big failure. Not a failure, but you know, a point against its health. That was a weird transition. It was supposed to be on the same page. And then we just need new people who are kind of interested in working on this thing, because I've done a lot, and to be honest, I'm a fine programmer, but I'm mostly just patient. I think we need people who are really good at working with hardware, who are maybe interested, have a new interest in improving support for RISC-V on FreeBSD. Oh, okay. Oh, okay, that's weird. So, okay, yeah, so the long-term viability of it. Here's one thing that I've been thinking about. If we compare the kind of, what is the market share that RISC-V is going to succeed in, and we compare what is the market share that FreeBSD generally is targeting or succeeding in, I think there's not a major overlap. I think RISC-V kind of presents a compelling choice when what you're producing is really small embedded chips that you know, maybe where licensing fees would be a problem, or you just need something really custom. But when we're talking about you know, these little embedded boards that run full-fledged operating systems like FreeBSD, it's hard to see what advantage there is to running RISC-V at all compared to x86 or ARM64, which are years ahead in terms of their maturity. You know, if all we're going to get is kind of the same thing, but with a, you know, freely licensed ISA, like I have my doubts about that ever really catching up and taking over. And so to me, that is a little bit of a problem when it comes to why are we building this thing. the other kind of aspect that it might be is that, you know, RISC-V in some way seems to be targeting this kind of world of like micro VMs, and essentially part of what they have created with the supervisor binary interface is we want the OS kernel to be unable to tell / it behaves exactly the same whether you're running in a hypervisor or on bare metal, which kind of tells me that this is like one of the main areas that they're looking for is, oh, we want RISC-V to be like a virtualized first kind of architecture, which is, I don't know, the way things are going. But for me personally, like it starts to not resemble a computer, and so I don't really understand it. Yes, we continue to refine our target platforms, we being FreeBSD. We continue to kind of be decisive in removing things. MIPS and Spark now gone. 32-bit platforms are next. And this is to our benefit because it reduces the maintenance surface of the kernel and the operating system as a whole. Every CPU architecture that we support has a really big cost. Even, you know, the points in RISC-V favor where it's kind of not special, that reduces that cost, but it's still big. So I'm not suggesting that we axe this thing. I'm just saying that we need to evaluate it on a continual basis whether the effort that is being poured into it is something that is moving towards something concrete, or if it's just holding us back. And yes, as John mentioned this morning, the survey results of kind of what people are interested in, what platforms they're interested in, that's really helpful for making those types of decisions. So, you know, maybe what I'm kind of curious about is the people who are interested in RISC-V, like, and who maybe responded so on the survey, like, in what capacity are they interested in it? Do they just want, you know, are they just hobbyists who want to kind of mess around with the new latest thing, or do they have a different type of view on it? That's all I have in terms of slides. It's been an hour, so now's the time for, I don't know, any kind of discussion about this, or we gain some time back. So anyone have any thoughts or questions at this point?
Yeah, so I mean, on the Cherry project, we're interested in RISC-V essentially because it's where all CPU research is being done today outside of corporations. Basically, if you want to play, then you must have RISC-V. Also, there are paths to product there. For the Cherry side, there's Codasip has some announced IP, 64-bit application processor sort of IP that we will be porting FreeBSD to, and hopefully we'll see silicon next year. So that will be very exciting. And that, you know, if people pick that up right now, if they want to pick it up and run Cherry on it, then they're running FreeBSD. You know, there are plans to do Linux and everything, but it's a big chunk of work.
Yeah.
So potentially a huge advantage for us. I think, you know, yeah, overall though, like the current ecosystem doesn't match where we play well. I totally agree. You know, the question is probably, do the established players, you know, innovators dilemma themselves into the corner and let RISC-V eat their market at the bottom until there's no bottom. So I think it's useful for us to chase it, you know, while things continue to grow.
Yeah.
If they stop moving up market, then then it's time to think hard about
Yeah.
what makes sense.
Thank you. That makes sense to me.
So what's your sales pitch to get new blood?
I don't know. I didn't think that was my responsibility.
Well, what drew you to working on this?
I mean, I wanted to learn more about operating systems, and that was kind of and I wanted to learn more about kernel development, and that was kind of a big area that was not being worked on. So, so initially it was the kind of drive and desire to discover and know more. But having been through that, you know, I can't say that that motivation is still there. But, you know, it's a, you know, the problem of how do we get, you know, new people interested in working on this thing is the same as how do we get new people interested in working on FreeBSD in general. It's just if this kind of domain happens to be what they're most interested in.
I mean, do you think that that we might be able to get more new people to work on this because there's less people working on it, so there might be more opportunity?
Yeah, I think so. Well, like, for me as a student who was like still learning, that's what I saw was like, oh, this isn't, you know, there's not 10 people working on this every day. So in a way I can keep up. I can take my time to learn and because, you know, when you're learning, it takes you longer to produce things. So you kind of need to target something that's not changing every day.
I'm trying to think of the next question. But I mean, so do you think also, besides it being an opportunity because there's less people, do you think there's enough people to be mentors for new people in this area? Because I don't know who all. There is you and Reslan.
Yeah. You know, I think, I hate to say it, but the answer is no. Like, we have a shortage of people who are interested in working on FreeBSD on embedded platforms anyway. Like, there's quite a few, like ARM and ARM64 boards that, you know, have either never quite been completed or have been dropped, like, because, oh, we supported this at one time and now we're not sure if anyone's using it or if it still works at all. So I do see that as being an area where, you know, the expertise is like really, there's not enough to go around. Yeah.
This is a similar question to Deb's question. Have you received any funding from the provinces or federal funding for your work?
No, I haven't investigated that.
Interesting, thank you.
Regarding the market of the RISC-V, and I want to point out probably so China will have a large market share of RISC-V for so 5 years later or 10 years in 10 years time frame because they are
So ARM and Intel never hit their market because of the political conflicts. So so I believe that it is worth doing, and I appreciate your work about RISC-V, and we need to keep up with the things that Linux is doing, and mainland China, so the government will adopt the software grade in the future, the software grade RISC-V chips in their national infrastructure. So there will be a big market, and if it happens, we want to have a chance to get into the market. So we need to have, at this moment, we need to have the basic support for the RISC-V at least, and we need to maintain the people like you who are taking care of the RISC-V. So that is one of the reasons, in addition to the research, to support the RISC-V on the FreeBSD.
Yes.
So also a note from like a cybersecurity perspective. I think that especially nowadays, when there is a lot of emphasis on supply chain verification, I think that open platforms like RISC-V would be much more attractive, I guess, for vendors. So especially in like international situation. So I think it's definitely, there is a future there. So definitely keep at it, I guess.
Going along with that, there's also something to be said for hardware monocultures. I myself kind of don't really like software monocultures, so if we could, the more hardware that's available, the more types of hardware, the better. It increases the knowledge required by an attacker to perform a successful exploit. Also, are we ever going to see hardware, RISC-V hardware, that is budget friendly and just boots normal EFI, or are we going to still go down this ARM64 like rabbit hole where your choice is either Apple hardware or you got to have a lot of money for something that just boots normal UEFI?
Well, if ARM's not there yet, I don't know how to answer that exactly. Like, it's that's up to the hardware vendors, and I expect that it's probably more expensive for them to provide something when projects like U-Boot exist. Okay. I guess that's it then, unless there was anything on IRC. Cool. Well, I'm very polite. Thank you, everyone. It's been a pleasure.
Just got after Sven, we'll close out with Warner, who's going to give us some kind of warm up of his Bylaws talk. First, Peter, do you need to get set up with the projector? Yep. I can stall for time. Here.
this is also the mic you can use.
I'm fine with this one.
Oh, you go for it. That's fine. All right, you ready?
Yeah.
Go ahead.
So it's not going to be a real talk. It's just getting something rolling, maybe getting into a discussion. It's about we don't need any more or even more documentation. Getting started guides for ports and maybe base as well. So let me show you some quotes, which happened on the OpenSearch project. Was how can I just get the admin password changed? Or quotes like Pavel said, we don't need any more or even more documentation. Or lots of documentation isn't helpful if I can get the damn thing to run first. So let me show you an example. It's, I said, changing the admin password in OpenSearch. There's a nice documentation on the OpenSearch project. You see there's like a lot of stuff you can do, but finding how to change the password is like, yeah, it's nice to see all these things explained. SSL transport enabled. I'm pretty sure what it means, so I don't need the explanation. I just want to copy and paste something to get it up and running. Another good example is he actually works on the OpenSearch project, and he wrote on his own blog how to change the password, but it's Docker specific, so won't work on FreeBSD as well. So there's now a blog post about that they introduced how to change the password in 2.12 export and then run the installer, which wouldn't work if the port has already been built. So and putting it in your Docker Compose won't work on FreeBSD as well. So this won't work as well. So I decided to put it just on the wiki page. It's just one or two commands and a small configuration you have to do, just copy and paste it. The issue is there's more like these things in the OpenSearch project. It's what then failed was configuring TLS, because the TLS files or the certificates have to be in the OpenSearch directory because it's just linked and it won't get the full path. There has to be documentation on that, and finding that, I don't want to look it up on OpenSearch. It's on all these documentation. So yeah, there always has to be an AI-generated image, even if FreeBSD is not written correctly. What people might want is finding getting started guides. So just a simple page, yeah, do this and that, copy these files or getting these things up in place, and everything will work just for a demo setup. So I ended up writing it stuff on my own blog for myself. I use it oftentimes for BSD or setting up a putrea in jail. Yeah, so maybe there would be a way to get a single place for all FreeBSD examples, if it's mostly ports, but maybe also for base. Something like, just a suggestion, examples.freebsd.org, go to that web page, look for OpenSearch, and you're gonna find examples how to set up TLS, how to set up your password, how to install it. Package install isn't enough for jail-specific stuff. I know the documentation on all these projects on FreeBSD, OpenSearch, and whatsoever is very good, but oftentimes people fail even installing it or getting it up and running. So
yeah, maybe we can start a discussion on getting something like examples.freebsd.org or something like that up and running. Yeah, that's it. I'm not quite sure how to get the stone rolling.
This is needed because I spent 2 weeks trying to get open, not full time, 2 weeks trying to get open source running, OpenSearch running with Graylog, and I kept failing because of TLS issues. And the difficulty wasn't the documentation. The difficulty was comprehending the documentation and implementing it. If someone could have given me a small practical example, which would have worked off the bat, I would have spent a lot more time getting it running than I would have getting it run to run, if you know what I mean.
So what
Yeah,
oh,
there's more comments.
all right, I'll run the mic over. I'm happy to do that.
Yeah, I think I see a lot of similar things with students these days. That, I mean, the handbook has a lot of information and a lot of extra prose text around these examples. But I think with these attention spans nowadays, that's just too much. They don't want to read all that. They want to just get the copy-paste examples out of there and go on with it. And they don't even read what the prose text says. They just want to, you know, what do I need to copy into my terminal to execute it? I think that's a big problem these days, that we are now having so few or so little attention spans that if I tell students, look at this handbook page, they just don't do it. They don't have the bandwidth mentally or motivationally. And I think having that as a short guide, do this, do this, do this, and that, they see something happening, and then afterwards, okay, it's working, now I can read the whole thing, what have I actually done on my system. It's kind of a bad thing to do, but well, I guess that's, the times are changing.
So this is, you know, industry-wide problem, right? Which is that everybody wants to have an immediate answer to their question. But I wanted, I mean, I'm here, you know, sponsored as someone who participates in the community, and one of the things that we have to offer in, in AWS is we have a methodology for putting together what we call game days, which is a great way to introduce people to the experience of the environment without making them responsible for an environment, right? Just making something that's set up, broken, and now they have to fix it, right? And so it's a great opportunity, and it also has the option of scoring points so that you can figure out how it does. But it's a non-prescriptive learning environment, and I think that might be something that's kind of fun to add to this is what can we do in a non-prescriptive way that makes it super easy for others to get involved. And I personally would love to have those, you know, opportunities for people to be exposed to FreeBSD on the AWS platform, and have an opportunity to learn in situ by reading the documentation and tackling problems that introduce them to an experience of activating their ability to be an administrator.
Yeah, but I think that's comes later, setting up these environments. I mean, Dan has been here for a while, and if he has trouble just setting up OpenSearch, which has a very good documentation, just getting a TLS certificate in place for a just Java container, it's more than that, but I think, yeah, we really might need that.
Yeah, I've been saying for about 20 years, this is one of the reasons that Linux got more popular than FreeBSD. With FreeBSD, we had great documentation and things generally tended to work. With Linux, the documentation was terrible. You had to work really hard to make things work. And so if you figured out how to do something, you wrote a blog post about it. You told all your friends. We didn't have that advertising in FreeBSD because there was no great achievement to tell everybody about if you got something working.
Or you get Michael to write a book. That's the other solution. Okay, thanks.
I would just like to say that my usual tactic is to write a piece and then send it to John and say, do you really want me to put this in print or do you want to fix it?
Touche. Pavel?
So I think this is also like a cultural problem because I kid you not, but I was talking to someone many years ago and he was telling me that if FreeBSD will get easier and easier to use, he will stop using it. Because for some people, like this is some kind of filter that they feel more elite, I guess, if they use something which is really hard to use. And for me, this is like for example, I was always in all my manual pages, I put example sections, right? And I try to give examples because I don't want people to like read the entire manual page every time they looking for some quick help, right? And I think we should embrace this kind of thing. Like even for like manual pages, there should always be some short examples of some common use cases, right? So I definitely agree that we should have something like this. And another, maybe. Not sure how people will take it, but maybe we should have some like GPT agent in those examples freebsd.org because to be honest, I use ChatGPT for examples nowadays. I can quickly ask and give me some kind of like copy and pastable one-liner or some piece of code, right? Which is super easy.
Yeah, there was this talk at the BSDCan about the REC system. You've seen it as well. So this might be another thing, getting a REC and expert system up and running with all the FreeBSD specific stuff, a fine-tuned model. But yeah, that's another thing. Okay. Well, thank you, Finn. Thanks. Oh, never mind. So, thinking back several core elections, several core teams, I think it's time for a change with the bylaws. And so I've started writing up a little bit, kind of the direction I think we should go, but I'd like to have a community-driven discussion about that. Here's the current bylaws. Can anybody guess, except John, because I already told him, can anybody guess why some of it is highlighted in yellow? Most of it is highlighted in yellow. Those are areas that we've had problems with in the project. Or there's been an interpretation, like what is an active committer? You know, I made a commit 364 days ago and then completely disappeared. Can I run for core? You know, and then I resigned my commit bit even. Can I run for core? You know, there's all kinds of edge cases and loopholes in this. And we were very worried, or the core team was, if we didn't even get 7 candidates, you know, because that triggers a new election. So if you're in an election with 6 candidates, you're going to trigger a new election before you get out of the election. And that is no good. So I think core is too large today. And also our current structure burns people out in core. We all can think of examples of people who served on core and then went away. Now, sometimes that's because of code of conduct. That's because of personality conflicts. We'll go with personality conflicts. Sometimes it's just, there's only 1 or 2 people doing stuff, and after 2 years, you're just done. Because even though core is 9 people, and when we did the bylaws, we thought, hey, let's put 9 people on there. Somebody's going to be working all the time. Well, on some core teams, 2 people work all the time, and 7 have core on their resume. Okay, I'm being a little uncharitable, but not excessively. And part of it is that core's mandate is unfocused. Core is the governing body of the FreeBSD project. And with this group of anarchists, that's probably almost too long a description of what their job should be. Unfortunately, when you're on core, that doesn't give you a whole lot to go on. You don't have a set of rules to operate under. You don't have a set of rules to change. You don't have anything really to do except whatever your own best judgment is. And we've had mixed results with that. Sometimes it works really well. Sometimes it works less well. It also tends to be a very secretive group. I'm totally guilty of doing this. Outside of core, I want it to be public. Inside of core, I want it to be private. Because I don't necessarily want people watching when I give my frank opinion. But sometimes when people aren't watching, people in core can act like nobody's watching, act in a bad way. So I think we need to have something that's going to be a little bit more public, a little bit more out in the open. We won't have the black helicopter jokes anymore, but I'm willing to give them, put those in the rearview memory or rearview of history. And then finally, a big problem with core team is that it's only developers that have commit bits to a particular repository that have a voice in the core team, unless somebody on core also wants to speak for other people in the bigger community. I think we need to widen that somehow, make it a bigger community. And so the food for thought that I have is core should probably be 4 or 5 people, not 9. 9 people, it's too hard, even with easy consensus rules to get stuff done. And I'm thinking off the top of my head, and this is just throwing stuff up there. We have 1 person that the source committers elect, 1 person that the ports committers elect, and those are from those groups. Probably also docs as well. It's a little bit niche, but it's also a large enough and important enough community to maybe have a seat here. And then 2 seats that are kind of at large. And the 2 notions I had here, the first notion was everybody that has contributed in the past year might be 1 group. So that broadens out. It also maybe encourages contribution, which will be both good and bad. I have a talk on Saturday about contributing via GitHub. And sometimes we get too much stuff that we don't want. But and then 1 person elected at large from the whole community. But I was talking to John about this, and the last thing you want is to have that and then have it be like a Perl chatbot that gets elected because they can randomly generate thousands and thousands of different email addresses or something. So that's something to work on. And core's job would be defined a little bit more narrowly than it is today, or a little bit more succinctly, which is to manage the different hats that we have in the project. The different groups of people that are doing things would get a little bit more active oversight. Different groups that have had problems when core has been unable to do that over the past several years. We can come up with several examples, but I don't want to pick on anybody. And the other thing their job would be to create a roadmap. Now, this isn't a core telling the community what to do. This is core looking at the community, looking at the technology areas that we're in, looking at the industry as a whole and saying, hey, to be competitive, we need a better X. We need a better Wi-Fi stack. We need a better desktop experience, and maybe a little bit more detail. Or we need to support NVMe 2.0 a little bit better than we do today because it's starting to cause problems. Or whatever the issues are, and I don't mean to pick on anybody that's working in these areas. Those are just examples that you all might be thinking. And then their job also is to coordinate between groups when that's needed. So the release engineer kind of does this naturally, but there are things like policy around the length of branches are supported, say. That would be an area that they would need to discuss because, well, what works great for source and works great for ports doesn't work for the cluster because then we need to have twice as many machines if we do that. Or it doesn't work for our users because they can only run, only deploy FreeBSD for 6 months at a time or something. There's different balancing points to different support links that they would need to look at. As just one example, I mean, if our support policy is good there, they don't need to do anything. I would also make the core terms 1 year. And I haven't talked to anybody about this, but basically you can serve up to 3 terms and then you need to move on. And then we would have elections each year for this. Maybe we make it 2 years and we stagger it, I don't know. This seems simpler. And we probably also need some changes around elections. They're both too short and too long. The nomination period is too short, takes people by surprise. Sometimes people don't get to run because they're on vacation for 2 weeks. And the 4 weeks of voting seems a little excessive. It was designed with European summertime vacations in mind, and we don't really need to engineer for that. So that's kind of what I'm thinking around that. And have more of a mandate for public business. Not personnel issues. There might be some other private things, companies come in. But the vast majority of stuff that core does could be done in public. Although, it's, there might be unanticipated issues with that. But people filibustering or, doing other things. So I'm not entirely sure about that, but it probably is a good idea. So that's kind of the food for thought that I want people thinking about. I thank you, John, for giving me a few minutes to do that. Does anybody have any questions or comments? I don't want to get into all of the grists that might be fit for this topic right now, but I just...
We're a little ahead of schedule, so I think it's up to you how much you would want to discuss now versus over dinner.
Yeah, I can. Why don't I start with questions, and if they get too much, I'll stop.
And there's one over IRC that I'll go ahead and.
Okay, and then Doug over here has one.
Okay, all right. I'll play Vanna after this. So someone on IRC, I'm sorry, I don't know how to map it to a human. Asked why not make it a variable number with a corresponding notion of quorum. So I think they're asking why not have the size be fixed, but some kind of scheme where we have different numbers depending on how much activity is going on or something like that. I'm just sure.
Okay, I can interpret that in one of 2 ways. One is why not expand and contract the size of the core team based on something, either activity, as you said, John, or possibly the number of active committers that we have, or the number of active contributors or something. It's an interesting idea. A more interesting idea that I didn't put up here, because I want to make sure we try it in Source Manager first, but is to have a notion of, yeah, there's only 4 or 5 people on core, but core also has a number of non-voting lurkers, I think is the term.
Yeah, non-voting members who can
Yeah, non-voting members that see the deliberations, that see what's going on, that make up whatever subcommittees they might want to create to study a problem or to go look at a problem. What that would also do is that would allow us to train people for core, kind of fatten up our bench. We don't have enough people that are qualified to run for core. A lot of people are run because, hey, I'm going to run, and that's great, but they have a lot of problems when they get to core. And if we had a training program, they might have fewer problems. They might be able to try it out before they get into it too much and find they like it or don't like it. And that might give us, in total, a stronger candidate pool of people that can do the job better. So that's not exactly, the question that was asked, but it reminded me that I forgot a bullet point on here that we had talked about. So Doug is next, and then Colin, I think, is who I saw the next hand with.
Right, so I had two questions. About the term limits. If someone, I suppose we go with this model, 3 consecutive one-year terms, is there a timeout period where you can re-enter the system? Because if we don't allow people to do their terms, have a resting period, and maybe contribute again in the future, I think we're going to run out of people.
I think that's an excellent point.
I like the idea of the training program. That might help with that.
Yeah, I agree, and I wasn't sure how to put that on the slide, but you serve your whatever terms, and then you take some time off, and then you're eligible to go again. Would be kind of the notion behind that point, and that would keep new people rotating in to core, but while still providing enough continuity, I think. The one-year terms will let people commit more easily. Hey, I know my daughter's graduating in 2 years, I can't commit right now. I might be able to commit for a year and see where I'm at before the next thing. Maybe I'd be able to because there's, less of a need for my time when she graduates that becomes apparent, or maybe there's more of a need and I would have to, step down early if I had committed to 2 years to take care of that and really be fair to the rest of the group. There's also no real replacement strategy in the current bylaws. We go and we lose members until we get to be too few, and then we have an election. And that means people tend to stick around and not resign that should resign because they don't have the time for it, or it makes core reluctant to kick out a couple of troublemakers if they know it's going to be new elections. It just kind of sets the mindset for just kind of, well, you have these 9 people and you're stuck with them for 2 years, whether you like it or not, kind of tends to sink in, and that's not a good, constructive way to have a healthy, functional team.
Yeah, that kind of intersects with my other question. So you talked about the risk of finding something that could be attacked by a bot, and then you'd end up with some adversary on core. Is there a remedy for that? Is there, other than by dissolving and having a new election?
I don't know. I mean, it's just one seat on the one hand.
I mean, is it worth it? Maybe we already have this. Is there a mechanism for expelling some individual bot from core?
There probably should be. I mean, there is one right now. 2/3 vote can eliminate somebody on core. It's been used exactly once for somebody that didn't show up for 6 or 9 months on the first core team. There was no animus, or it's just we got tired of waiting a week for the timeout for him to respond. So we said, well, it's time for him to move on. And that we handled it badly, not terribly, but it could have been done better. And that having a way to do that might be good. But yeah, again, I'm not sure exactly what at large is, but I do think we have to find some way of having something that is someone on the board that is more representative of the whole community somehow. And I'm not sure how to do that. This is my first not so great guess. Colin, and then you.
So first on the issue of non-voting members of core, I absolutely agree. One thing some people here may not know is that the release engineer is automatically a member of the security team. I'm not involved in dealing with security issues, but I need to know if there's stuff that's going on because I may need to hold the release until some security issues are dealt with. And it's just easier if I'm on that mailing list and I see what's going on rather than hoping that somebody tells me in time to not do roll the release.
Oh yeah, we should CC the RE.
Exactly. Yeah. So yeah, it would be good to have the release engineer, for example, be a non-voting member of core, just so that they have some idea of what is being planned for the project. On the issue of who is, or the representation of core from different groups, we should probably look at whether the group that you need to be a member of in order to be eligible to stand for election is the same as the group which is voting for you. So when we're looking at the at-large, for example, we could say anybody in the world can stand for election, but the people who vote on that position are the committers.
That's an interesting notion. I think that's probably a good discussion point for whatever working group that I'd like to form to deal with this. I don't want to do this all on my own, and I don't want to pay a consultant to do it for me all on my own, because we all know how consultants work. But I think that would be a good kind of figuring out the right tension there, because if it's anybody in the world but just the committers voting on, it's really the committer's voice, not anybody, the larger community's voice would be what I would worry about an arrangement like that. Although, you know, having some vetted group of people that we know are real people that have used, you know, what is the third prompt in the sysinstall? You know, what's the third screen? If you can answer that, you can vote. You know, I don't know. I don't know what the right selection criteria would be to show that they're a part of the community.
Yeah,
so
I think the point I wanted to raise is, in fact, that I have heard that Linux Foundation is pushing projects in the direction of something like the Ops Trust model. Probably not as far as 3 handshakes are required to be a member, but I think they're pushing a number of key projects to no one can join if they haven't met someone. I think there are a lot of problems with that model, but if the wind is blowing that way, we need to not be the outlier who lets ChatGPT join. That would be
Oh, that would be fun. That'd be a fun press day for the core team.
It would be better than some cores, I'm sure, but
I'm officially not allowed to comment on that. Yes, Michael.
So if code of conduct was a non-technical matter and mentorships are non-technical matters, what room does this leave for the non-technical issues that the project faces?
That's a good question. Give me a second to think.
I think in some cases it's hard to say that mentoring is a purely non-technical matter. In that many of the cases.
Surely no, there are technical aspects, yes, but checking in on mentors is.
Right. It's.
Time can be later, right?
Yeah, because that gets into more of an operational thing that the core team is doing, what they do, what they don't do, and whether or not that's spelled out in the bylaws that everybody votes on or on some kind of charter that's kind of a companion document that's easier to change but not written in water, as they say. You know, I'm not sure how that would fit in, but at the bylaws level, I'm not sure we would, you know, need that. The at-large member, the notion of having an at-large member on core is to deal with the non-technical issues surrounding it. I just use it. Maybe it's somebody who has really good contacts in the field, and they just use FreeBSD to, you know, do, you know, publish papers or publish, you know, do biology research or something that, you know, we wouldn't even think of as being necessarily relevant. But since they are tapped into the community and can speak for the community, they make a good representative. So it doesn't really quite matter what they use FreeBSD for. I know all the examples I'm coming up with are technical, but that's the way my brain works. I'm not trying to, you know, be exclusionary in any way with that. So that's that. I don't have a good answer, but that's I think a little away from the topic that we have. I mean, it is something that the new core will need to deal with, absolutely. But I'm not sure that's a good starting point for the bylaws. I think one thing to keep in mind, one of the things that was in yellow, I'm pretty sure, is that the current bylaws are rather hard to change. And so there's some tension with what things do you want to codify that you want to make very hard to change versus what things do you want to be something that gets kind of, that is more written in water. And so it's subject to kind of being interpreted. And it is helpful, though, to kind of reason through a lot of the different things you want to think about, including some of the watery things, to kind of help narrow down the scope of what needs to be water or not. So a lot of that discussion you do need to actually have, and knowing at the end several things you might decide that doesn't need to be codified quite in stone.
Right. And you might also come to the conclusion of core shouldn't be doing that at all. So there's no need to waste any time codifying what they're not doing. They're not approving source commit bits, so we don't need to have anything about source commit bits in the core bylaws, for example. Or at least I wouldn't think, but. So any other, I don't know your name, unfortunately.
My name's Rob.
Nice to meet you, Rob.
You too. Thank you. This might be a little naive because I'm still fairly new here, but how do you see the relationship between this kind of change with the Foundation's work? I realize the two groups are somewhat at arm's length. However, they're, like you've talked about, like setting some directions, oh, we need better NVMe support, I think was the example you had. The Foundation also has its priorities, things it's trying to, get sponsorship for, get people on board to do, and so they're going to want to be somewhat aligned, you would imagine, given that where the money is coming from to actually fund some of the really hard stuff is going to have to match up. I don't really have a specific question, just more like...
Right. I can say a few words about that, though. Yeah. So the few words I would say about this are the Foundation for years has been wanting input from the project about what the project wants. And sometimes they get it from the project because the core team then that's there is with it and can say, hey, these are the things that we want. Not very often. Usually, and the other extreme is they ask and they get nothing. Usually it's some vague hand-wavy thing that's not very useful. One of the notions is that we have the core team stop managing the day-to-day bits in the source tree, and that gets devolved to another group, which we're calling source manager, much like port manager and whatnot. And that gives the core team more time to be thoughtful and come up with even just, the three most important things that FreeBSD needs are, whatever those three things are. And they can work better with the Foundation then. And I'm hoping that it will improve the relationship between the project and the Foundation, and they can be more in sync than they are today. Sometimes the Foundation reads the tea leaves of the group very well and funds the right things. Other times they read it less well, maybe not fund the right things, or maybe they don't just have the right people to know. And it's kind of hard to know, or that need to do the right things, but they have people to do other things, so they do that instead. And without being good, close communication between the leadership of the project and the leadership of the Foundation, it's hard to really know what's going on there. You don't really know, oh, the core said fund wireless, and they're doing desktop and no wireless. If that's very public, that you see that disconnect, or you see the Foundation say, oh, we don't have an engineer to do the wireless, so we're funding this other thing that was number 4 on the list or something. You can see that play out a little bit better in public, and people understand better what's going on. And by doing that, core will do their job better, and the Foundation will do their job better. Again, I'm not trying to criticize anything the Foundation is doing specifically, just I think that there's this source of friction today, and we need to acknowledge it. So I think that's kind of my
notion for what having a slightly different structure would also by the project. So.
And I might, that was most of what I was going to say, with one additional caveat, which is the foundation is not the only entity that funds work in the project. Like on the recent graph, we see that Netflix funds quite a bit of work in the project as well, right? And I think part of what you want is for core to operate at a bit more of an abstract or higher altitude, where it is also it is doing the same kind of conversation about when trying to evaluate like a roadmap. You're trying to get a sense or a gauge of what is our community doing, and that has lots of inputs. It has like the user survey, which is an input from one set of people, versus talking to our corporate sponsors who do fund a lot of work, or talking to the foundation who kind of is in that same bucket too, right? You need to talk to many people to kind of get a sense of what's going on in the project and then find out what are the common threads and themes, and I think that's how you actually develop what your kind of roadmap is going to be over the next period of time. It's not dictating as much as it is trying to actually codify and coalesce and kind of pull the common threads out of what people are doing, so then you can have clarity for people to know what's kind of where we're actually all going. Otherwise we don't know we're all going that direction. We kind of are. But then people can make better informed decisions about how to spend their volunteer time, about what things are going to be more aligned with what other people are doing, and where are we kind of as a group all headed.
Yeah, exactly. It would help the core team lead the project a little bit better, because the project's going in a direction it's going, whether the core team says boo about it or not.
Yes.
And we might be able to reinforce our efforts that are desirable, and maybe discourage some efforts that are not quite so desirable. Nobody wants a FreeBSD PDP-11 port. I mean, some people might, but the project doesn't.
We are not the home for a PDP-11 port.
Yes. You can run 2.11 BSD on that, and the last patch update was in the last 3 months. So
we'll give you a tape.
I'll give you a pointer. There's no tape machines on the PyDP-11s. It's all virtual. So we'll give them a virtual tape. And this is why we can't let that happen. We want Colin working on other stuff. I think Jonathan, and there was a hand over here.
Yeah, I just want to put in my 2 cents that I think the question that Michael asked earlier is really important about the non-technical bits, and I think that I think you really should spend some time, or we should spend some time this evening thinking about that. And any sort of rewrite you're going to do here, I think should make clear who's going to be doing that non-technical work. And if it is going to be the core team, I think that should be very clear, and the expectations should be clear as the people running for it know what they're getting themselves into. Because that work is actually really important, and someone has to do it. So I think that's an important question to clarify and make clearer going forward.
Yeah, and it also occurred to me that this group will be doing a lot of management, and that's not necessarily technical. So I got hung up a little bit on the examples too. So that's a good point. So.
And we're down to about 5 minutes left.
Okay. I only need about 30 seconds to wrap up. So we can either give people 5 minutes back, or this discussion with Andy will be 5 minutes.
Yeah, with regards to the term in number of projects that I've worked on and where I've been on boards and committees, etc., they've staggered the election.
Mm-hmm.
So with each year, there is an election of either 2 or 3 people, depending on how many come up, and those are for 2-year terms, and then you have that overlap period for consistency, for handovers, etc. And that's worked far better than having ones where everyone's elected for a year term and it just kind of rolls on. Sometimes you have a complete flush and it's like crap. It takes them 9 months to work out
ask from elbow, it's like, well, that was a fat load of use. Then they get elected out again because they haven't done anything. Well, they've not had a chance to do anything. So
Yeah, those are some of the trade-offs we'd have to consider, and those are very good points. We tried several years ago to amend the bylaws to do that, and we tried to do too many things all at once, and so they failed. We've always had at least one member of continuity from core team to core team.
by luck, though, rather than by design.
By luck rather than by skill. So.
Excuse the naivete, but who would be the, for want of a better phrase, chair of core? Or would that be an elected person, unelected, appointed, anointed, born? But yeah, I mean,
No, that is a good question. That's something I had totally forgotten about. There probably does.
who's the responsible person? Because ultimately somebody needs to take the kicking when things go wrong.
In the past, we've never had a chairman of the core team. Jordan was a little bit at first, just because he kind of had done a lot. But that is a good question to have, whether we have that organization or not, and if so, how do we pick? How do we select? Is it the person that gets the most number of votes in this process? Is it, the 5 members vote among themselves for something? It's a good question.
It can't be the most votes unless you have the same electorate.
Yeah, that's true.
You're not the first to suggest that either, by the way.
Yeah, that has been suggested, and having a larger pool of people to form subcommittees so that work gets done and that can be changed out a little bit more easily as energy level and time level commitment ability, changes over time. So.
Okay, so I think, looking at the back of the clock, I think you need to wrap up and we will transition to dinner and we can continue discussing there. So I'll
okay, so
finish.
I don't really have a wrap-up slide, but the only thing I wanted to say was that even though I put together this straw man, this is the starting point, not the ending point. It's easier to talk about something that's there than kind of things that are abstract. And so what I'd like to do is I'd like to lead the larger community, not just developers, not just committers, but the larger community that is interested in how we govern the project, so that we can create a good set of bylaws in the end. And we might be able to get some help for that group, depending on how things work out.
Do you have a goal in terms of a timeline?
Oh, a timeline. I'm hoping that we'll have this done. I would like to have it done by next BSDCan, but realistically, I think it might be the one after.
But in particular, my thought is before the next election.
Before the next election, yeah, would be ideal that we vote on this and then shift to the new structure, whatever that structure might be. And it might look a lot like what's on the slide. It might look completely different once we've had a chance to talk about it and think through some of the implications. Oh, we're doing that and that has this problem, or oh, we're doing that and it's fine. So.
Okay.
So that's all I really had. So I'll let you wrap up.
All right, sounds good. Thanks, Warner. Okay, so that ends today's program kind of material, our track for today. So we do have dinner tonight as a group. It's in the bottom floor of the residence building, 90U. If you don't know where that is, reach out and grab someone else. They probably do. Or just keep grabbing people until someone tells you where it is. But it's more or less kind of across the street that way-ish. So there's a ground floor lodge and residence, or ground floor, not lodge, lounge. That's where we'll be meeting.
We'll provide pizza and sodas. Some people may bring other beverages, but that's your own responsibility if you do that. Don't tell the university. And then tomorrow morning we'll be back here. I think we start again at 9. You're not like time zones away. So we'll be back here tomorrow. We have a full slate of stuff tomorrow morning. I think we actually start off tomorrow morning talking about release engineering. So that should be lots of fun. Colin's gonna be so excited. So see you at dinner and back tomorrow morning.